Hi dear students, greetings of the day. Today, myself, Ifteqar Rajkumar, and my colleague Ifteqar Sir, we both are going to deal analog electronics questions in GTQ. So in this two modules I am going to complete today, that is one is diodes and BJT. The remaining modules, MOSFET and op-amps, my colleague Ifteqar Sir will take that session. First 1.5 hours I will take, the remaining session will be completed by Ifteqar Sir. Sir, in GATE exam in electrical, I observed that diodes, basically they are asked one question compulsory,
Yes.
op-amps also,
Yes.
but BJT or MOSFET,
Yeah.
sometimes BJT, sometimes MOSFET.
Yes.
So according to the view, I can tell that for electrical students, diodes compulsory, you can expect a question, but in BJT, MOSFET, there is a choice, any one question can come. But op-amps wise compulsory, two questions compulsory is coming. So op-amps everybody knows it's a very important topic. Now, we'll ask some question in EC session, how the questions are coming. Ifteqar Sir will tell you something about that.
Yes, greetings of the day, dear students. We welcome you both. We will welcome both electronics and electrical students to this session. Coming to electronics gate questions, if you observe last 10 years of papers, they are asking questions frequently from MOSFET topic, MOSFET biasing, MOSFET amplifiers. And then the second important topic for electronics is op-amp, and then comes diode. In the last 10 years, BJT questions are not so frequent, but like last 2 years, they did not ask question from BJT, but there is a hope that this year there must be a question from BJT also.
BJT, I think
Yes.
we cannot tell anything.
Exactly.
They can give anything.
Yes.
BJT or MOSFET,
Yes.
but they are similar devices. So when you practice BJT, MOSFET also will look same.
Yeah.
So don't leave any session. Okay?
Yes.
Both are important.
Yeah, now Rajkumar sir will take up questions from diode and BJT. Later I will be discussing questions from MOSFET and op-amp. Yes sir, please carry on.
Thank you so much, Ifteqar Sir. Okay, thank you. Oh, hi. Now analog electronics and diodes and BJT I'll cover. Okay. Let's see the first question. So this is my first question. You can observe this question one time, students. In this question, I have given a Zener diode concept and normal diode, both will be covered. Just you visualize what will be the answer for this. Just I will wait for some 30 seconds or 1 minute. Then I will start explaining the question to you. So one time I will read the question. Consider the circuit in the figure. Let V gamma is equal to 0. V gamma equal to 0 means cut-in voltage of a diode is 0. In Zener diode also, forward bias it will have cut-in voltage, and normal diode we have cut-in voltage. So for both the diodes we have cut-in voltage is 0. Plot V0 versus Vi. Is asking you a graph how an output V0 will respond to the input Vi. That is the question. Generally this type of questions we call it as clipper questions. Okay. So generally the best method to solve any clipper question is an open circuit test, is one of the best technique to solve the problems. Let me show you one time the model. If I take open circuit test, suppose if I start drawing open circuit test for this, I will write here open circuit test. Open circuit test is nothing but just open the diodes and see how the circuit looks. This is 10K, this is Vi, Zener diode is open, normal diode is also open, and we have some resistance of 10K. You can see the circuit is looking like this. Both the diodes are open here. When both the diodes are open, what will be the potential here? We can expect is 0 volts, because in the circuit there is no current flowing. So at that point we can have 0 volts, and as the current is not flowing, this position will be VIN. So these are the positions I am seeing in the diodes. Zener diode position is like this. In this direction you can see Zener diode, and normal diode is in this position. Okay. By seeing this, now I am going to analyze the characteristics. First my analysis is, On the other side of Zener diode, we have 0 volts potential. So, let us start. Negative voltage, that is below 0, what is happening? If I write a condition, first condition, Vi is suppose less than 0. I started like this. When the input is less than 0, you can see that Zener diode is coming into forward bias, because anode side we have 0, cathode side you are telling less than 0, which is a negative voltage. So, that Zener will become forward bias. Whenever Zener comes into forward bias, it behaves like a normal diode. When it is in forward bias, how it will behave? Zener diode also will behave the same manner. So, I can expect Vi less than 0, Zener is on in forward bias. Okay, Zener diode is on in forward bias. Whenever this is coming into on condition, this potential will go to the normal diode, and that normal diode is also taking the negative voltage, where the anode side is ground, cathode side you are getting some negative voltage. Therefore, normal diode will also become on in forward bias. So, both the situations are telling both will come into on condition. Whenever both comes into on, this will work as a direct short, this will work as a direct short, because the cut-in voltage of the diode is 0 he has given, such that this is short means the output voltage he is expecting how much here is. When the normal diode is on, the output will become equal to 0, because a short parallel to 10K will become 0. So, this will be the first situation I observed. And coming to the second, 0 less than Vi less than 3. Why I have written 0 less than Vi less than 3 means there is a story of Zener diode here. Zener diode in reverse bias, it will be off, everybody knows that. But after 3 volts, he has given some breakdown voltage. After 3 volts, Zener is coming on in reverse bias. The specialty of Zener diode is it will be on in both sides. In forward bias also it will be on, in reverse bias also it will be on. So, 3 volts when you cross, Zener will come into on condition. So, in this condition we have not crossed 3 volts in reverse bias. So, Zener will be off here. In this duration, Zener will not react anything, it will be off. When Zener is coming into off here, no current is flowing here. So, 0 volts, other side is 0 volts. So, normal diode will also become off. Okay, both the diodes were coming into off status. If Zener is off, diode is also off. Can I expect your output will be again 0, because no current is flowing in the circuit, again response is coming 0. But when the input is greater than 3 volts, if you cross 3 volts, Zener will come into on condition in reverse bias, in breakdown voltage it will come. So, Zener will be on in reverse bias, where normal diode, what will happen at that time? Zener will be replaced with a battery of 3 volts, such that the other diode is getting some negative positive voltage, because you are giving positive voltage to the cathode. So, diode will remain off only, such that your output will be Vin minus 3 volts. Okay, sorry, your output how to write, now we will see. So, we have to write the output for this. Just roughly I will draw the diagram to understand better for this. This is 10K, this is Vin, we have a battery of 3 volts. Zener diode is replaced with 3 volts battery in reverse bias condition, and normal diode is open only, and we have a 10K resistor. We are taking the output for this. Okay. To find out this, first we will find out the current in this loop. First we will find out a current, how much in this loop. The current is given I is equal to Vin minus 3 divided by 20K. So, this is the current flowing in the circuit. That current into 10K will be the output. So, V0 will become I into 10K. that is VIN minus 3 divided by 20K into 10K. So, this is the expression I am getting, where the answer I can write here is VIN divided by 2 minus 1.5. So, this is the expression we are getting for this V naught. Okay. So, finally, output is coming VIN by 2 minus 1.5. He is asking you the characteristics, how to draw for this. To find out the characteristics, let me draw here the characteristics for this. This is your input and your output. Let me take some other color to show you clearly the waveform. Up to 3, your answer, the output voltage is 0. Up to here, you do not have any output voltage. Okay. Okay. After 3, you have some straight line equation. You have some straight line equation having a slope of some 0.5 slope is coming here. So, it is having some slope of 0.5. So, you can expect a graph like this in the concept. Okay. So, this will be the output characteristics with respect to the input, how the circuit is behaving, you can understand. So, you can just watch this solution. I will just see the comments what the students are giving, just I will observe the comments. Yeah. Good evening to dear students, good evening. Very good evening. So, I hope this is very clear, the explanation is very clear. So, let us analyze now the second question dealing about the diodes concept. So, one thing you can learn in this problem is normal diode will be on only in forward bias, but Zener diode will be on in forward bias also above the cut-in voltage given, and it will be on below the reverse bias also it will be on, but with certain breakdown voltage. In this problem the breakdown voltage is 3 volts. You should know that fundamentals to solve this type of questions. Okay. So, now yeah, Aman, fine here, Aman, good evening. Thank you, Aman. Thank you so much, Aman. Let us move to the next question. Let us deal the next question. So, this is my second question. Most of the questions comes in gate exams will look like this, something related to some current sources. Sometimes they will confuse you because most of the times we deal with voltage sources, but sometimes they deal with current source, suddenly student will get disturbed. So, let us take up this question, how to deal. I will show you the question now. Meanwhile, you can analyze the question, just I am giving 30 seconds to 1 minute time for you. Here he has given assuming a constant voltage drop model with V gamma is equal to 0.6, means the diode have a cut-in voltage of 0.6. Plot V naught as a function of IIN. Most of the times we do with V naught versus VIN, but in this question the specialty is V naught versus IIN. Input current we have to find out. Okay, anything, no problem. It also looks like a clipper question. So, any clipper question comes, do not get tension in the exams. Only one best technique we can use is open circuit test we can apply. See how casually we can complete this problem. Again I deal with open circuit, one of the best technique, open circuit test. Just what I will do is, I will take a current here, IIN, next we have R1, next we have open, just open the diode, nothing to do. We have some voltage here as VD, diode voltage of VD, just I made like this. Now, the only thing basically a student knows is when the drop of a diode is greater than 0.6, diode will be forward bias. When VD is less than 0.6 cut-in voltage, diode will be off condition. There are only two things basically we know that will apply it. If VD drop is greater than 0.6, your diode will be on and it will be replaced with a battery 0.6. It will be replaced with a 0.6 volts. So this is the situation I know. But what is VD in the circuit here is, it is defined as current IIN into R1. This is VD coming in the circuit. Now what I will do is, this function in terms of current, if you analyze, IIN into R1 is greater than 0.6. This is the meaning of VD greater than 0.6. But we want IIN function, so IIN should be greater than 0.6 by R1. So this is the story of VD with linking to IIN. So what I understood is, if your current IIN is flowing in the circuit, if it is greater than 0.6 by R1 times, then your diode will come into on condition, okay, that we can expect in the problem. That means if the IIN is greater than 0.6 by R1, if diode comes into on, the reverse condition will be, reverse condition, if VD is less than 0.6, your diode will be off, which is replaced by open circuit. In reverse bias we are taking open, that means IIN into R1 should be less than 0.6, that means IIN should be less than 0.6 by R1. So this is the situation you can see. So he is expecting a graph between output voltage to input current. So let us draw a graph for this. This is the graph, IIN function and x-axis output voltage. Now I will take another color for this. What is the boundary limit here we are getting is 0.6 divided by R1. Okay. First, when the VD is less, IIN is less than this position, your diode is off, you are telling. When diode is off, that IIN into R1 is flowing. So this side we have output voltage is fixed to 0.6. Okay. So we have some line coming here, which is IIN into R1 up to this position. After that it is becoming on, so 0.6 is fixed. You can expect this type of graph where the slope of this line is R1. So I am expecting this response from these conditions. Just you can check one time the solution. So this is the way how to deal in gate exams. They will not ask you very tough questions in gate level. I have seen every year what they are asking, very fundamental questions. Basic grip if you do not have in diodes, then it will be complicated. If you have fundamentals good, every question you can do it casually. Okay. This is one good idea I can expect. These are the two questions we have completed today. Ishita, very good, understood, nice. So this completes the two questions. So let me move to the next question, that is problem number 3, dealing about one more diode question now. We will go for another question. This is a very beautiful question I have designed. You can see very having good concept. That's only gate examiners want this type of questions to ask in the exams. Abhi tak this type of question has not came in gate, may be expected in future they can ask you this type of questions. Let us see the good concept in this problem. Correctly, if you see the question, assuming VIN is Vm sin omega t, plot the output waveform of the circuit. He want the output waveform to show in this problem. Figure for the initial condition of 0.5 volts across the C. Capacitor generally, when we deal the peak detector circuit, this is a peak detector, we call the circuit name in analog electronics. In peak detector, what we explain in the subject is initially the capacitor is uncharged. In textbooks also they will write like that. But suppose if the capacitor is charged initially, then how the response will come for the output waveform is a very interesting idea. So let us see how I will predict the answer for this. 0.5 volts is already charged here. After 0.5, maybe when diode comes into on, it will charge. Let us see how the waveform can be written without any analysis. Directly with the waveform, we will write the output answer. Okay? Just I will show you the output directly with some analysis. Directly by seeing the board, we can analyze this problem. So let us see how I will analyze. No need of any steps here, just visualization is very important here. This is T I have taken, and this is your V naught. Sure, we will try to analyze the answer for this. Okay. So this circuit generally we call it as peak detector, we call this as peak detector, which will detect the peak value of the signal. Okay. What is my analysis here is, initially the capacitor is already stored with 0.5. That means when the input start from 0, when the signal is starting from 0, when it is crossing like that, positive value it is going, how much energy that signal required to make the diode on, that you have to think. Here generally diode requires 0.7 energy to make it on, but not only that, here capacitor is also having 0.5 volts. That means to overcome the diode to make it on, how much energy I have to give from the input is not only 0.7, 0.5 also we have to add. That means 0.7 plus 0.5. Total energy we have to boost to make the diode on. So 0.7 plus 0.5 will be the input we have here up to this input, that is 1.2 volts. Up to this 1.2, your diode is telling I will not be on, because the energy what you are supplying to the circuit is not enough. So up to 1.2 volts signal, your diode is not conducting. If diode is not conducting, capacitor is already stored with 0.5 volts. It cannot discharge both sides, because this side is open, that side is also open. So that's why what it will do is, it will hold this value 0.5. So I can expect another color I will take for this output, I will take another color. So I can expect 0.5 volts. It will maintain up to this point. Up to 1.2, it will maintain 0.5 volts constant voltage. Okay. Next we have this peak value he has given as 5 volts, maximum it is 5. Then my output will go how much? When diode comes into on, what will happen? If diode comes into on, it will have VD on voltage, battery we have to substitute 0.7. The circuit looks like this then. When diode comes into on, it will be positioned with 0.7 here, replaced with 0.7, VIN, and this is a capacitor of C with 0.5. This is your output. Now the capacitor got a chance to charge more than 0.5 now. But how much it can charge? If you see, it can charge 0.5 to 4.3 volts. Maximum it can charge up to 4.3. Because you have given maximum 5 volts. If you apply KVL 5, one side diode has taken already 0.7. But then capacitor has to take only 4.3 volts. But if the capacitor is not initially charged, it will charge up to 5. But basically already it is charged with 0.5, it can charge only up to 4.3. So I can expect it will charge up to 4.3. One time the capacitor is fully charged up to 4.3, if the signal comes falling down like this, the diode will not becoming on, it will become off for you, because the cathode voltage is dominating here. 4.3 volts maximum it has charged, so that any signal comes down like that, so the anode will become less than cathode, so that the diode remains off and it will saturated the value of the output is 4.3 because capacitor cannot discharge when diode is off. So, this type of response is expected for the special type of concept called peak detector analysis. I hope everybody understood. It is not a very complicated explanation, very simple explanation I have done. Up to 1.2 volts below the signal, your output will be 0.5. That is my first explanation. Above 1.2 volts, if you cross, diode will come into on condition. When diode comes into on condition, your output will be VIN minus 0.7 will come. VIN is maximum 5 minus 0.7, it will be 4.3. That means capacitor will charge up to 4.3. After charging 4.3, when the signal is coming down, the diode will become off because of anode cathode conditions. It will become off, so that we will get the what I can say steady state value of the peak detector is 4.3. Okay, this will be the response we can expect for this type of question. Okay, I hope everybody understood this question. So, with this we have been covered 3 questions. Let us move to the 4th question. Okay, I hope everybody understood this question who is watching this video. So, now we will go for the 4th question. So, Zener diode, you know that in competitive exams, GATE or engineering services, very beautiful questions they will ask you about regulator concepts. I have been kept one regulator question here. So, everybody knows in regulators what will be the components we have. One is a series resistor, we will see. One Zener diode will be in shunt, parallelly one resistor will be there RL. For this question, what is asking here is determine the minimum value of RL. In this question, they have not given RL, we have to find out the RL. How much the resistor we have to place in the circuit, minimum value, such that the Zener will be in on position to work like a regulator. That is the question. Just I will give time for you, analyze this question. Analyze this question, I will answer this question for you. You can check the answer. Who is preparing for GATE? You should not take more than 1 minute in these questions. Below 1 minute you have to solve this type of questions. Okay. Anyway, in regulator also the same story. We will make the Zener diode open here also. What will happen if I open the Zener diode? Open here, open circuit test will do it. This is 220 ohms. We have open. Next we have some load. This is RL, minimum you want. For VL, how much means 10 volts. We need the load voltage is 10 there. When load is 10 volts, Zener diode will maintain 10 volts. So, load we want 10 volts, RL minimum we have to find for that. So, what will be the formula first I will write for this is VL voltage will be, apply the voltage division rule, VI into RL minimum divided by RS plus RL minimum. So, I have written this equation. In this we know that VL should be 10 volts because we are ensuring that the voltage across the Zener to be 10. So, 10 will substitute here, input is given 20, RL minimum is unknown, divided by RS plus RL minimum. So, this is why you are expecting the equation in the problem. Okay. Already one student has given the answer, 1.83 kilo ohms, Rushil Patel. Rushil, let us see the answer. Let me verify the answer one time. So, this answer will see 10 into RS is 220 ohms plus 10 times of RL minimum will be equal to 20 times of RL minimum. Okay, how much we are expecting here is, it is 2200 plus I think equal to 10 times of RL minimum. RL minimum we are expecting here 220, 200 by 10, 10 is cancelled, 220 ohms. So we are expecting RL minimum as 220 ohms we are expecting. I think some students are getting here 1.83 kilo ohms. Kumar, everybody is telling 1.83 kilo ohms. Okay, it's not 1.83 dear, it's coming around 220 ohms for this question. Please check one time your answers. Ishita is telling 247 ohms. Just verify your solution. In this problem, power is not required, dear students. Some people are doing with the power calculations. Power is not required. Power is only to make you get confused. I have given this because we need here VZ to be 10 volts is asking. So VL is enough there. If VL becomes 10 volts, then VZ will maintain 10 volts. It's only after all one what I say voltage division will complete. Because sometimes in the exam point of view, some data is not relevant to the question, but they will give the compulsory so that the student will get going in a wrong direction. They will make you to do these problems. Here power is PZ max is not required here. PZ max when you require is whenever they ask you IL max, IL minimum, whenever you want the type of answers, that power calculations are required. Okay. At this moment, this one step is enough to solve the question. So RL minimum we are expecting to be 220 ohms. Let us move to the next question. This is also a very beautiful questions in gate level. We are expecting these are called multi-branch diode problems. Okay. If you are technically you know the circuit logic already in the subject, it's very fast to do these problems. Otherwise, we have to do testings and we have to solve it, all these things. Generally, if you know the behind knowledge about the standard circuits, it will be very comfortable to solve the problem very fast. If you see this question correctly, this type of structure in digital electronics, we call it as OR gate, we call this as first logic. I am writing by seeing the circuit. We call this as OR gate circuits. Generally in OR gate, what is the theory we have in digital electronics is, whatever the inputs you are giving, which input is a high voltage, that will respond, output will respond to that input. That is called OR gate techniques. If you see here 10, 5 you have given, D1, D2 both are looking forward bias, but in this logical circuit only one diode will respond, the other diode will not respond because of the technique called high low inputs. So if I use this logic gate technique directly, so for Vi1 is equal to 10 volts, your D1 will be on. For V2 5 volts, whatever you are giving, D2 will be off. This is the situation directly we can write. Otherwise, we have to go for short circuit test, open circuit test, we have to do all these things. If you know already, it's better to solve the questions quickly like this. So for 10 volts, diode will be on, for 5 volts it will be off. And in this problem, he has given when diode is on, V gamma is given 0.6. The RF, which is called forward resistance of the diode, is 0. So what I will do is the modeling will come like this. This is 0.5K, this is 10 volts with a battery. We have here 0.6 with a 9.5K with output. We have V naught. I think your circuit looks like this for this design. Okay, because the D2 is not responding here. So Vivek Kumar is telling 9.5 volts. White Rapper is telling 9.5, Sharad 9.5. Is it some students are getting same answers? Whether you are at one place to give the same answers, I am not understanding. Exactly, if it's the wrong answer also, same answers you are writing. So let's see, the answer you are telling 9.5 to 2 or 3 students are telling. Let's see what will be the answer for this. So first I will find out the current in the circuit. The current in the circuit is 10 minus 0.6 divided by 10K. This is the current. Okay. Then output V naught will be equal to current into 9.5K. That is 10 minus 0.6 divided by 10K into 9.5K. KK is cancelled. It is 9.4, that is 0.94 into 9.5. You are getting something voltage V naught. How much it is? Let me calculate. Yes. Now I think the Sharad and White Rapper has changed the answers. Very good. Now your answers are good. Nice answers you said. Previously you done some mistake dear. Please check that answers. 9.5 into 0.94. It is 8.93 volts is coming. 8.93 volts. This will be the perfect answer for this question. Okay. So this covers how many problems we completed? 5, approximately 5 questions. This is my analysis about the diode questions. In diodes, most probably in GATE exam, please remember the main topics which a student should practice. I am telling you, clippers is very important. Most of the questions you have seen clipper questions only, and the best questions you can see based on diode modeling techniques and rectifiers and regulators. These are the very important modules to cover in GATE exams. Okay, in diodes mainly I am telling you. So this covers my today explanation about diodes. Let us start a next device which is a BJT, bipolar junction transistor analysis. Okay. Total 10 questions I prepared, 5 questions we completed, remaining 5 questions we will see now. Based on BJT, now I will analyze the questions. Okay. I hope up to here it is very clear to dear students. Let me show you the BJT problems. Yeah, the first question came, very interesting questions I have designed. See the question. Carefully observe the question. Who is preparing for GATE exams? This is my first question. How it is looking for you, this question? I think in our class, when I am analyzing to my students, this circuit, if this is not there, okay, only that above circuit, everybody knows, my students will tell very comfortably that it's a fixed bias, because most of the times we practice these circuits very well in the classroom. It's a fixed bias circuit. But what this person has done is, in place of emitter side directly short, he kept a transistor. Okay. A student should know the basic meaning of the transistor, how he connected here. If you see the technique here, the base and collector is shorted. Whenever you do BJTs like this, they will behave like a diode, because a 3 terminal you made only 2 terminal. So that is the reason in VLSI integrated circuits there is no manufacturing of diodes, because the scientist who designed this concept, he understood that when there is a BJT we can make a diode, but if you have a diode we cannot make a BJT. So that is the beautiful concept how we applied. So it's a diode actually. It's not a BJT now, it's a diode. Diode will have some potential here, VB, base emitter voltage. In DC analysis, it will have a potential here, VBE, and we have current here, IB, and we have current here, IC. This person is asking you operating current IC how much? First we can apply an input loop here, KVL at input loop. We can find out the IB current, base current, which is equal to 2.5 minus 0.5 minus 0.5, which is cut-in voltages, divided by 100K, which is coming to be 1.5 microampere. I think 15 microamperes is coming, not 1.5. It is coming to be 15 microamperes. Okay. This has been disappeared. There's some structuring problem here. Anyway, this is 15 microamperes we are getting. Okay, there is a problem here. I hope you already seen the question. So 15 microamps we are getting. So we'll find out the IC current, which is equal to beta times of IB. Beta for this problem he has given is 100 into 15 microamperes, which is coming to be 1.5 milliampere. So this is the way how to deal this type of question. So don't get tension, some adjustments they will do in the problems. You must know the story behind the design. Whatever the Q2 transistor he connected, he has taken from a concept of active load analysis, which we deal in op-amps, integrated circuits. It's a BJT. When you connect base collector as a short, we said diode, it's not a BJT, which will have some potential of 0.5. After all, we can apply KVL and we will finish this answer. So the answer for this question is 1.5 milliamps will be the correct answer. Yeah, come in. It's stuck in, it's not coming actually. Okay. So no problem, leave it. Yeah. Suddenly it has disappeared. So anyway, you have watched that question. Okay. There is a problem about this. Some issue is coming in the board. We'll go for the next question. Next question we'll see. Yeah. Most of the students have given 1.5 milliamps. Very good. Karthikeya, Manish, Sakshi, Rushil, Vivek, Sharad, wonderful answer. Good year, nice. Gyan, active load, correct. Great year, good. You are following the answers, good. Let me go for one more question in BJT. Please watch the question. Just see the question one time. He is asking you in this problem the voltage gain of the circuit. He is expecting the voltage gain how much for this circuit. Okay. First of all, this circuit is a common base amplifier. I will write here, circuit name is a common base amplifier. How, sir? How it is a common base? Simple. The input, this is a PNP transistor given. The input we have taken from emitter. Input is coming from emitter. The output we are taking from collector. So only the base is common here. That's why it is a common base amplifier. Generally, who is going for gate exams, they should not write models neatly, small signal modeling, writing answers. It takes a lot of time actually. You must straightforward know the technique. If gain you are asking, what is the formula of that? Straightforward with formula you have to finish the problems. Within 2 steps I will finish the problem, you can see. I know only one basic formula for voltage gain of common base. I will write here. Voltage gain. AV. Standard formula here is RC. This is RC resistance, load resistance. This is R0. R0 is also given. So generally load becomes here in AC model RC parallel to R0. This is your load. divided by small Re, which is the dynamic resistance. This is the formula. Just one time, if you know the formula directly in amplifiers, what is the need of writing models, small signal models? Within one step, I will finish this problem. The only thing we have, the time which I am spending here is for DC model analysis, because Re, which is the dynamic resistance, always we can find from the DC analysis. Re value, Re, which is treated as a dynamic resistance. Dynamic resistance. The formula for Re is Vt divided by IE. Re formula is Vt divided by IE is nothing but operating current. Here, if you take the cut-in voltage, in the problem, if you observe, they have not given cut-in voltage. Please remember this. Okay, I have not given. That is the reason to explain for the students. Why? Because in gate exam, suppose they are not given any voltage. Default in the classroom, I will tell you, default knowledge is very important. 0.7 is the cut-in voltage. If you take 0.6, it will become wrong. If you take 0.5, it will become wrong, because there are some default conditions in analog electronics. So I know 0.7 is the default if they don't give. So we will find out a current in this loop to get IE current. So IE current here, it is 2 minus 0.7 divided by 1K, which is 1.3 milliamperes. So this is the IE current. So if you know the IE current in the problem, just substitute for the gain here. It is a 5K parallel to 1 mega ohm here given divided by 1.3 milliamps. If you are an intelligent student, you never take calculations and make the time waste. 5K parallel to 1 mega ohm according to the network's concept. 1 mega ohm is a very high resistance. Sometimes they make you infinite also. Sometimes they will give 1 mega ohm. But I feel that 5K, if you are comparing with 1 mega ohm, it looks like infinite only for me. Unnecessarily, I will not waste my time. I will write 5K by 1.3 milliamps. Because high resistor parallel to low resistor will be low resistor only we will get. 5K by 1.3 milliamps. Okay. Sorry. Here I done small mistake. Here 1.3 milliamps, here we should not write. We have to write small Re. First we have to calculate small Re. Vt is 26 millivolts divided by 1.3 milliamps, which is coming to be around some 20 ohms something. Okay, it's coming to be around 20 ohms. So here we can have 20 ohms, which is 5000 by 20, which is coming to be around 250. So I am expecting your gain is coming around 250. Sharad, you are very close to the answer. It is not 248 dear. It is not 248 Sharad. It is 250 will be the answer for this question. Maybe you have taken Vt as 25 millivolts. We should not take like that. In the question, if they mention 26 millivolts, we have to take 26 only. Whatever you like, we should not take in gate exams. If they don't give 26, then default you can take it as 25 millivolts. No. Okay. So this will be the analysis I can do it. Small signal model I am not drawing for this, because straightforward gain formula we can apply and we can solve these questions. Most of the times common emitter questions will come, but sometimes to make the student to confuse, common collector questions, common base questions will come, but they are not very much tough questions. They are very narrow questions and narrow applications also. One time if you have in your mind what will be the answer for certain input resistance, output resistance, gain, current gain, if you know the basic things, it is very easy to solve the problems. Every year you can expect one question from amplifier. Either it may be a common emitter or common base or common collector. In MOSFETs we can say common source, common gate and common drain amplifiers we can expect. Okay. Vivek Kumar is asking, sir, can we solve with IC by Vt? Yes, you can solve IC by Vt, Vivek Kumar, but IC by Vt becomes GM. I think this formula a person can also write it as GM into RC parallel to R naught, because here GM is 1 by RE. 1 by RE you can solve, GM you solve, no problem. But RE reverse answer is GM, which you are finding there, no problem. Anything is okay. Okay. GM is called transconductance, which is reverse to the dynamic resistance. Okay. Anything you can solve. But finally, my answer is for this question will be 250 will be the perfect answer for this question. Okay. So I hope everybody understood this question. Let me move to the next question. We'll do the next question. Yeah, this is one more. Ishita, yes, in analog numerical data type of questions, definitely you can go for approximate answer also, exact answer also, because that is the reason they will give a gap of answer for you. They will give some range for you, 245 to 250 something they will give range, or 247 to 254 like that. In between the range, some people will do approximation, some people will do exact answer. That is the reason they will give the range in numerical data, so no need of tension. You can go for exact, you can go for approximate, it will be fitting in that gap. Whatever they give in that gap, it will fill the answer. Okay. So no need of any worries in analog electronics. You can do it. Nice. One more very good question you can see here. Very interesting question, which I have designed myself. Given small signal models of BJT. Everybody knows in small signal analysis. In small signal analysis, if you see, small signal analysis, if you see, in BJT we have three models. One is called hybrid parameter model, the second is RE model, and one more we have is RPi model. In this question, they have given RPi model here, which is RB dash model, we call RPi model. Low frequency model, RPi. In this side, they have given H parameter model. Sometimes this type of questions also expected in gate exams. HIE, in the first model, we call it as input resistance of that model. HIE, we call it as input resistance of hybrid model, which they have given 1.1K. Other side, they have given RB dash E, that is also considered an input resistance of the RPi model. But generally, if you see the input resistance seen from here for this model, we are getting it as HIE. But if you use this model, the input resistance we are getting here as RB dash plus RB dash E. So if you equate these two models, we are getting a relation here, that is HIE is equal to RB dash plus RB dash E. So this is the way how you can equate the relation between these two parameters. In the question they have given HIE, RB dash E, they are asking you RB dash how much? RB dash how much? Yeah, Vaibhav Mena, GTQ series will cover all the questions. You just follow the questions, okay? And the next session, Ifteqar Sir will take. He will explain you op-amp good questions and MOSFET also. You follow all the questions what we are teaching here. Okay, this will be a plus for you for gate exams. You can expect this type of questions in the exams. So one time you watch all the questions. Don't neglect these questions. Okay. Based on our experience, we are giving these questions for you. HIE is given 1.1K. RB dash is unknown here. RB dash E is 1K. So RB dash we are getting here 100 ohms. So this is the way how this problem can be solved. A student should have a basic knowledge of models how to equate in the subject. That will make this type of questions very easy for the student and very funny to solve this type of questions. Okay. Anyway, the answer will be 100 ohms. Most of the students are telling 0.1K. 0.1K or 100 ohms, if both are same, good. Sometimes in the fill in the blanks, if they give ohms, if you write 0.1, it will become mistake. Previous year students, so many times I observed, this, they are not observing that ohms, kilo ohms, then writing fastly 0.1 like that. Carefully observe what units they have given, according to that you have to write the answer. Be careful. The question is easy, knowledge you have, but when you are dealing the question, you have to observe correctly the data given in the exam. Otherwise, unnecessarily you have good knowledge, but you are failed in the question. So be careful when you are analyzing, observe the question carefully. Okay. This will be the second question of my BJT analysis. Now, coming to the next question. Next question. Yeah, John, your habit is using small signal model. Yeah, John, you can use small signal models and you can solve it, no worries. But GATE exam does not have time to solve all the small signal models. Sometimes you have to use small signal when it is not a standard question. If the question is a standard one, no need of any small signal models, directly formula you apply and solve the problem. If it is not known to you, then apply small signal model. Okay? For everything if you apply, there is no meaning of GATE exam. Speed is very important. So, if you see here, calculate the feedback factor is asking. Feedback factor beta is Vf by V naught for the given circuit. This circuit, without doing that feedback analysis, I will solve with some technique now. You can see how I will solve with a technique. The feedback voltage is here, first point. Re is the feedback and output we are taking from here. We are taking the output from here. This is V naught. First of all, this amplifier name we call it as an analog, common emitter, unbypass. We call this amplifier name as common emitter unbypass amplifier. What is the closed loop gain for this amplifier? Means closed loop gain AF, which is a closed loop gain. Closed loop gain. How much for this? Is standard formula I am writing. Okay. It is RC divided by RE plus small re. This is with minus sign. It's a common emitter amplifier, so we have 180 degrees phase shift. So the gain answer have been presented here directly, RC by small re plus capital Re. But comparing with capital Re with small re, Re is always much greater than small re. So the gain formula we can expect minus RC divided by capital Re. This much knowledge I have in amplifiers. Then we will see what is the relation between AF to beta in feedback analysis. In negative feedback, the transfer function AF becomes A by 1 plus A beta. This is the formula I have. Closed loop transfer function of a negative feedback system. Okay. A by 1 plus A beta, but according to the loop gain A beta is always much greater than 1 in negative feedback analysis. Therefore, finally this answer is coming 1 by beta. So you should have this type of techniques to solve the problems now. That means I understood if you want to find beta value, which is a feedback factor, it is a reverse to the closed loop gain. Already I know the closed loop gain answer. So reverse, if you take beta value, which is 1 by AF, the answer is minus Re by RC will be the answer. This is one technique I can use. In analog we can teach a number of techniques. There is another technique is theorem wise I can teach you, but this is a smart technique which we can practice. First, if you know the amplifier straightforward, the closed loop gain you find out. From the closed loop find, reverse that answer, because Vf by V naught is also a voltage ratio. So this is the best technique for you to solve problem immediately. Okay. So for this question, beta is minus Re by Rc, and I forgot to tell you what type of topology it is. If you see, the feedback is here, output you have taken at collector, but feedback is going at emitter. So this is a sample of current is going here, sample. So it is a current, and RE is a series resistor. So the topology name also I am giving, it's a current series topology, because this RE is connected in series to the signal. Whenever RE comes, it will become a series feedback, and output when you are not taking it emitter side, it will become current sampling. So it's a current series topology. Okay, I hope this question, I hope you understood it. This is about the negative feedback module questions. So you can expect some questions based on negative feedback or oscillators. If oscillator is given, they will leave the negative feedback question. If they give negative feedback module, they will leave the oscillator questions. So these two modules are very important, I said, in the classroom. So don't neglect this type of questions. Okay. Sometimes they may give directly circuit, and they will ask you what is the topology name, directly they will ask you. Okay. This is one module you can cover. So please just observe the question. Two more questions are there, I think, to finish off today. My module will be completed. Remaining module my colleague Ifteqar Sir will complete, because total 10 questions I prepared. So total 8 questions have been completed already. Just 2 more questions, I will try to analyze it now. Okay. So let me go for the next question. I think this is the last question, I think. Total 9 questions have been completed already. This is the final question, I think. After this, we don't have any question. Yeah. This is the final question of my analysis. One more module I have taken is the differential amplifier questions, may be expected with BJTs or MOSFETs, most probably BJTs. So you can see a differential amplifier question it is. How I will deal this question, please observe it. Determine the gain of a degenerated differential pair shown in the figure. These resistors we call in analog electronics as degenerated resistors. Degenerated is nothing but a negative feedback resistors. They work like a negative feedback resistors. So he is asking you the gain of the system. If you see the output here, it is a balanced output you have taken. It is a balanced output. You are taking the balanced output. So you want the balanced gain how much for this problem. How I will analyze the concept, you can see. Gain is nothing but you are doing some AC analysis. Whatever the DC potential you have here, some potential is there DC wise. That potential will make it ground. Okay. Some DC potential is there here, VDC, that I made it as ground. When you cut this circuit into 2 parts, and the VCC is also ground because we are doing AC analysis, I just cut this circuit into 2 parts. When you are making 2 half circuits, they look like this. This is one transistor with RE, ground. This is RC, VIN1. This side we have ground. This is V01. This is Q1 transistor. Next we have Q2 transistor. We have RC. This is ground, V02. This is VIN2. And we have RE2 ground. So you are seeing the model like this, cutting into 2 transistors into 2 separate positions. Carefully observe the technique. This is ground, cut this part, I am seeing 2 designs. How I will tackle this problem, you can see. This separate, if you do, we know some basic amplifiers in analog, fundamental amplifiers. This is a common emitter unbypass, where there is a feedback resistor RE. This is also a common emitter unbypass. 2 amplifiers we have now. This is a common emitter unbypass amplifier. This is also a common emitter unbypass. Okay. We will find out 2 separate gains first. that is V01 by VIN1, which is your AV1. First I am calculating the gain of common emitter and bypass. The answer for this will be minus RC divided by RE plus RE. This will be the formula, gain of the common emitter and bypass. Okay. So if AV1 is completed, but we don't want AV1, we want a differential gain of the first transistor. What is the definition of differential gain of the first transistor is AD1 differential amplifier is V01 divided by VD. Is expecting this answer. V01 by VD he wants, but VIN1, how it will be related to VD in the differential amplifier is, one side in differential amplifier my input will be VD by 2, other side my input will be minus VD by 2. So in differential amplifiers the difference will be cut into two half parts, one side VD by 2, one side minus VD by 2. So you want this relation, but I have this relation with me. What I will do is just V01 by VD by 2, I will write here. But you want only V01 by VD you want, the 2 we do not want. Then answer we can write it as minus RC divided by 2 times of RE plus small r. So this will become the AD1 answer. First differential gain, unbalanced gain I have completed. If you come to the second gain, AV2, the answer is V02 by VIN2 is again minus RC by RE plus RE. Again this formula is also same, but this VIN2 is equals to minus VD by 2. VIN2 is equal to, again we got problem, this is getting errors. Yeah, came by chance it came again. Okay, so this is the minus VD by 2 is nothing but VIN2. So what we'll do is we'll arrange this part, otherwise we'll cancel it. This one is missing. If I am touching this, is missing. So we'll write here the answer will be V02 divided by VD by 2 is minus RC by RE plus RE. But we want here, minus VD by 2. Okay, but here we want AD2 formula is AD2. The formula is V02 by VD. We want this answer, V02 divided by VD. This minus, if it goes there, minus of minus it will become plus, and 2 will come here. So it will become RC by 2 times of RE plus small re. So this will become AD2. So AD2 we got, AD1 we got. Based on the knowledge of amplifier, I am finishing this problem, converting into my style of gain formulas. Gain formula how you want, I am converting into that style. So AD1, AD2 we got, but we want balanced gain we want. If you want balanced gain, which is AD, which is a balanced gain, the formula will be AD2 minus AD1, which is equal to RC by 2 times of RE plus small re, minus of minus, it will become minus RC divided by 2 times of RE plus RE. So just I added this 2, minus of minus it will become plus, so 2 will be cancelled. So the finally my answer for balanced gain for the system will be, answer will be RC by RE plus small re. I think this will be the gain of the system. So this is the way how you can deal some differential amplifier technique questions. So finally to end up my session, I want to suggest to students who are preparing for electrical and ECE, always don't think about this is important, this module is not important. You should not think like that, because any question who is designing, suppose I am designing the gate paper, I'm very much interested and have a good expertise in BJT suppose, and op amps I'm very interested, diodes I am not interested, or MOSFET. The questions will fall on BJTs and op amps. Who can say that? Depending on the examiner psychology, the question paper will be designed. So you cannot say that sir, this year BJT will come, this year MOSFET will come. Nobody can tell, but we can predict it by seeing the previous year questions. But prediction also not required. Everything, each and every point, clearly if you can understand it, with the help of that knowledge, any question you ask, we can deal that questions. That's why it is not a BTech 4 years concept. In gate level always, you should have a foundation on all the points equally. If you prepare some concepts very good, some concept you are not prepared well, in that the question will come, then you will be gone. That's why you should have equal importance for every module what we prepare in competitive exams. Okay. So all the best dear students who are preparing for the GATE exam. Thank you so much for watching this video. Now my friend Ifteqar Sir is going to explain you very good questions he designed. He will explain you based on op amps and based on MOSFET. Thank you so much. I am giving the mic to the Ifteqar Sir. Just wait for 1 minute. He will adjust all the things and he will try to start the session. Thank you so much. Thank you.
Once again, greetings of the day dear students. Rajkumar Sir has taken up some good questions on diode and BJT circuits. I will be taking up questions on op amp circuits and then some questions on MOSFET circuits also. Okay, so let us begin with first questions on op amp. In op amp topic, there are three areas from where questions can come. Okay, op amp circuit having negative feedback, op amp circuit having positive feedback, and sometimes they can ask question where op amp will be in open loop condition, I mean no feedback. So in this session I have tried to take up questions from all these three areas: negative feedback, positive feedback, and also no feedback. Okay, so let's look at this first question which is based on an op amp circuit. Here you can see both negative feedback and also positive feedback. Now in this type of circuits we consider negative feedback to be dominant. Okay, there is a negative feedback and also positive feedback here. Output connected to inverting terminal and output connected to non-inverting terminal also. So this circuit has both negative feedback and positive feedback. Now in this circuit we take negative feedback as dominant, and the reason is feedback voltage at minus terminal will be greater here as compared to feedback voltage at plus terminal. So we can consider negative feedback dominant and we can solve the question. Okay, so everyone make a sincere attempt to solve this question. Okay, this is an MSQ, a multiple select question, where more than one option can be correct. So what we will do is we will calculate output voltage and load current. Okay, to find that output voltage and load current, we will be using the technique of virtual short circuit. Let us use virtual short circuit here. Between minus and plus terminal, we can consider virtual short circuit. Let us name this as node A. Okay, this as node B. Then we can equate VA and VB. Okay, V minus equal to V plus. We call this virtual short circuit. I am using here technique of virtual short circuit. V minus equal to V plus or VA equal to VB. VA equal to VB. Now to calculate VA, I will use one formula which will be very helpful. You can remember this formula. Whenever you have two resistors in series, okay, let us say we have resistors R1, R2 in series. Okay, this 5K and 10K, they are in series. So when you have two resistors in series and let us say voltage V1 present here and V2 present here, then I can calculate voltage at this center node Vx by using superposition theorem. So I suggest you all to remember this formula. I call it superposition formula. If you apply superposition theorem, you will get Vx equal to V1 into R2 plus V2 into R1 divided by R1 plus R2. This will be very helpful, especially when you have two resistors in series and you want to know voltage at the middle node, then you can use this type of formula, V1 into R2 plus V2 into R1 divided by R1 plus R2. You can use another approach also. You can apply KCL here and you can calculate VA, but this will be more comfortable or convenient formula. Everybody should remember this. Okay, तो हम यहाँ पर ये वाला formula use करेंगे, Vx equal to this much. VA I will calculate through this superposition formula. VA, it will be V0 into 5K, V0 into 5 plus 2 volt into 10K, 2 into 10 divided by R1 plus R2, 5 plus 10, and that is equal to VB. How to get VB? Between B and ground we have 1K and 1K in parallel. Okay, 1K and 1K, they are in parallel. This parallel combination you can take it as 0.5K. Okay, this parallel combination, it will be how much? 0.5K. Then the 2K and 0.5K, they are in series. So I can calculate VB with voltage divider, V0 into 0.5 divided by 2K plus 0.5, V0 into 0.5 divided by 2K plus 0.5. Now you simplify this, you will get V0. इस expression को आप simplify करिए, you will get the value for V0. For example, we can cancel here common factor 5, so it will become V0 plus 4 divided by 3 is equal to V0 divided by 2.5, or you can say it will be V0 divided by 2 V0 0.5 divided by 2.5, it will become 5 by 25, V0 by 5. Is that okay? V0 divided by 5. Then simplify this. 5 V0 plus 20 is equal to 3 V0. Okay. Or if you solve this, you will get V0 equal to minus 20 divided by 2 minus 10 volt. I am getting output voltage minus 10. So in the given options, option A can be taken as correct, option B is wrong. Then we will find out load current. To calculate load current, you can find out VB through voltage divider. Let me write here VB. Apply voltage divider. It is V0 into 0.5 divided by 2 plus 0.5 minus 10 into 0.5 divided by 2 plus 0.5. You will get VB minus 2 volt. Okay, minus 10 divided by 5, it will become minus 2. Then IL can be written as VB divided by RL. Load current equal to VB divided by RL. So it will be minus 2 volt divided by 1K. You will get load current minus 2 milliampere. So in this question, we can take option C as correct, option D will be wrong. So finally, the correct options are A, C. Okay, option A is correct and option C is correct. This kind of question can be asked for 2 marks in the gate paper, and I hope everybody has tried this question. Yes, I can see here answers from Anuj, then Rushil, Ashish, Vivek and John. Yes, dear students, this negative feedback op-amp questions are relatively easy to solve. In this negative feedback op-amp circuits, you have to use virtual short circuit, right? Then we may apply sometimes voltage divider, like here I have used voltage divider, and you may use this superposition formula and KCL. Through these 4 techniques, we can solve questions on negative feedback op-amp circuits. And there are some special cases also where a virtual short circuit becomes invalid. For example, if the output voltage is saturated, virtual short circuit will be invalid. If op-amp has smaller open loop gain, then also virtual short circuit invalid. And if op-amp has positive feedback or no feedback, then also virtual short circuit invalid. Okay, so everybody should remember these special cases also, because based on that also questions have come in the previous gate papers. Is that okay? Here we have applied virtual short circuit and we considered negative feedback to be dominant. Okay, feedback voltage at minus terminal will be greater as compared to feedback voltage at plus terminal. So we can take negative feedback as dominant, and whenever negative feedback dominant, we can apply our virtual short circuit property. So this was one question. Let us move to the next one. Let us try this one. It is like a numerical data type question. You have to find out V0. There are 2 op-amps and we have to calculate output voltage V0. So dear students, just have a look at this question and try to answer it. There are 2 op-amps here. Let me name them A1, A2. This I am calling A1. This I am naming as A2. This output, let us take it as V01, and this output let us consider V02. Okay, and these are op-amps having negative feedback, so we can apply virtual short circuit. Let me apply virtual short circuit here. Let us call this as A, node A. This I will call node B. So if I use virtual short circuit, I will get VA equal to 4, virtual short circuit, VA equal to 4 volt and VB equal to minus 2. minus 2 volt. Next, we will look at these resistors 1K and 1K. They are in series. Okay, everybody knows input current of op amp 0, right? In this branch, current will be 0. This current will be 0, right? So this 1K and 1K, they will be in series, and because they are in series, I can apply once again my superposition formula. Okay, I can calculate this node voltage through superposition formula, and that I can equate with 4 volt. Okay, now what will be voltage at this node? It will be V01 into 1 plus VB into 1 by 1 plus 1. Okay, superposition formula. Let us apply that superposition technique. VA equal to 4 volt, and we will find VA through this superposition. V01 into 1, V01 into 1 plus VB into 1K. That VB is minus 2. So let me write minus 2 into 1K divided by 1 plus 1 is equal to 4. This you can solve. V01 minus 2 is equal to 8, right? 2 into 4, it will become 8. I will get V01 equal to 10 volt. So in this way, I got answer for output of A1. How much? 10 volt. Similarly, we will calculate V02. I will use superposition formula for this node also. This is basically VB. That VB I can write as V02 into 1K plus VA into 1K by 1K plus 1K. VB equal to minus 2, and we will calculate VB through superposition. V02 into 1, okay, V02 into 1 plus VA into 1, that VA is 4 volt, so 4 into 1 divided by 1 plus 1, and that is equal to minus 2. This you can simplify. V02 is equal to this will become minus 4, and then minus 4 minus 4, it will become minus 8. I got V02 how much? Minus 8 volt. Okay, this 2 into minus 2, it became minus 4, and this 4 you bring here, it will be minus 4 minus 4 minus 8. Okay, so in this way we got V01 and V02, but हमें यहाँ पर फाइंड करना है V0. अब V0 कैसे फाइंड करेंगे? फिर से सुपरपोजिशन वाला फॉर्मूला अप्लाई करेंगे, राइट? 1K and 2K are in series here, so to calculate V0 I can use superposition formula one more time, right? V01 into 2 plus V02 into 1 by 1 plus 2. V0 is equal to V01 into 2 plus V02 into 1 divided by 1 plus 2. V01 how much? 10 volt. 10 into 2, that is like 20. Okay. V02 into 1 minus 8 into 1, it will be minus 8 divided by 3. So 20 minus 8, it will be 12. 12 divided by 3, you will get output 4 volt. So in this question we get V0 how much? 4 volt, and I hope you have tried this question. Yes, Anuj, John and then Arsh have given the correct answer, 4 volt. Very good to know, beta. If you are solving this type of questions, then definitely you will be able to attempt such questions in the gate paper. Okay, I have selected some good variety of questions based on negative feedback op amp circuits. Okay, so I repeat once again, to solve this type of negative feedback op amp questions, you will apply virtual short circuit. Sometimes we may use voltage divider, superposition formula and KCL. These 4 techniques are helpful in answering questions on negative feedback op amp circuits. And whether it is a student of electronics engineering or electrical engineering, if a question comes on negative feedback op amp circuit in the gate paper, then definitely you should attempt that question. Okay. Then let us move to another question. Now these are questions where we had op amp and resistor, right? These are called linear circuits. Is that fine? These circuits, they had op amp and some resistors, and they are like linear op amp circuits. Op amp in the linear region, and we are using resistors which are again linear elements. So these are like linear op amp circuits. Let us now take up one question where we have a diode. Now diode is a non-linear element. Okay, in case of diode, current has a exponential dependence on voltage. So diode is considered as a non-linear element. So this can be considered as a non-linear op amp circuit. Okay, here op amp will be in the linear region, but diode is non-linear. Okay, so this is like an op amp circuit which comes under non-linear application. Let us find out output. In the circuit shown, op amp is ideal and diode current follows this equation I naught into e power v by vt minus 1, where I naught is equal to 2 microampere. Please make a correction here. This is actually 2 microampere. Normally I naught will be like micro or nanoampere, so please take it as 2 microampere. Vt 25 millivolt. If Vi 2 volt, then what will be V naught? Okay, we will indicate here current through the diode as I, voltage across the diode, let us call it as V. Okay, we will first of all find out this current I. That same current I can show here also, because this current will flow into the diode, right? It is a single path. Current I will flow into 50 kilo ohm and then into diode. तो पहले हम current I find करेंगे. You can apply virtual short circuit, that V minus will be 0. Due to virtual short circuit, V minus equal to 0. अब आप current I find करिए. Vi minus 0 divided by 50k. Vi minus 0 divided by 50k. It is like 2 volt divided by 50 kilo ohms. This value you can calculate. 2 volt divided by 50. I am getting 40 microampere. 40 microampere. Now this 40 microampere current is going to flow into the diode. Okay. Now we will calculate voltage across the diode. अगर हमें current through the diode पता हो, then we can easily find voltage across the diode by using this equation. अब हम ये equation use करेंगे. Is that okay? Current equation of the diode, I equal to I naught into e to the power v by vt minus 1. इसको आप rearrange करिए बेटा. Take I naught this side, take 1 also this side. It will become 1 plus I by I naught is equal to e power v by vt. Then take natural log, take ln. Right, you will get v equal to vt into ln 1 plus I by I naught. Everybody knows how to rearrange the current equation of diode. Okay, this equation we can write in this form, and from here we can find out voltage across the diode. V equal to Vt is given here 25 millivolt into ln 1 plus I by I naught. Current I हमने यहाँ पर फाइंड किया है 40 माइक्रो, एंड I naught how much? 2 माइक्रो. I naught प्लीज टेक इट एज 2 माइक्रो एम्पियर. ओके, तो आप यहाँ से वोल्टेज V फाइंड करिएगा. दिस इज लाइक ln 21 multiplied by 25, 76.11. I am getting V equal to 76.11 millivolt. Then we have to find out output voltage. Now to find output voltage, we can equate this potential difference 0 minus V naught. That potential difference should be equal to V plus drop across 3.1k. Okay, to calculate V naught, we can equate potential difference. This potential is 0 and this potential is V naught. So 0 minus V naught should be equal to V plus drop across 3.1 K. 0 minus V naught is equal to V plus 3.1 K, 3.1 into 10 power 3 into I. Okay, और V naught equal to माइनस ऑफ V कितना है बेटा 76.11 मिली वोल्ट प्लस दिस इज लाइक 3.1 इंटू 10 टू दी पावर 3 इंटू करंट I. अब आप करंट I मिली एम्पियर में पुट करिए, यू विल गेट ड्रॉप, दिस ड्रॉप इन मिली वोल्ट प्लस मिली वोल्ट वी कैन डायरेक्टली ऐड. ओके, करंट I हमने यहाँ फाइंड किया था 40 माइक्रो एम्पियर, या फिर हम लिख देंगे 0.04 मिली एम्पियर. तो आप करंट का वैल्यू लिखिए बेटा 0.04 मिली एम्पियर. आई होप यू अंडरस्टूड इट. मिली एम्पियर इंटू ओम्स, इट विल बी मिली वोल्ट. Milli volt plus milli volt we can directly add. We should be careful with multiplication factors. Okay, this is a common mistake that we do in the exams. Be careful with multiplication factors. That is my hint, right? My suggestion to you. Be careful with multiplication factors in the gate paper. Normally in the exam, when our mind is under so much stress, we commit this type of silly mistakes. Okay, so be careful with multiplication factors. मैंने resistance लिखा है ओम में और करंट मैंने पुट किया है इन मिली एम्पियर. तो मिली एम्पियर इंटू ओम इट विल बिकम मिली वोल्ट, और ये ऑलरेडी मिली में है तो हम डायरेक्टली ऐड कर देंगे. ठीक है, लेट मी फाइंड आउट दैट 3.1 इंटू 10 पर 3 मल्टीप्लाइड बाई 0.04 प्लस 76.11. आई एम गेटिंग 200.11 मिली वोल्ट माइनस 200.11 मिली वोल्ट. यू कैन टेक नियरेस्ट वैल्यू माइनस 200 मिली वोल्ट. ओके, माइनस 200 मिली वोल्ट, या फिर आप लिख दो माइनस 0.2 वोल्ट. ओके, अप्रोक्सीमेटली माइनस 0.2 वोल्ट. So what will be our answer here? Option C will be correct. For this type of question, answer is option C. Yes, Manish. Then student named study point 92. Prachi, Vivek, John and Arsh. Yes beta, minus 0.2 volt is the correct answer, option C. So this question was a combination of op amp and diode. Okay, the diode is a non-linear element, so we can call this as a non-linear op amp circuit. Okay, let us take up another question. Now in this question, op amp is ideal and you should calculate magnitude of transresistance gain. Okay, that output voltage divided by input current, that ratio is called transresistance gain. We know well gain will be of 4 types: voltage gain, output voltage divided by input voltage, then we have current gain, output current divided by input current, we call it current gain, right? Then we have trans conductance gain, load current divided by input voltage, then trans resistance gain, output voltage divided by input current. This is actually a current to voltage converter. यहाँ पर input current है and output will be voltage, so we actually call it a I2V converter, current to voltage converter. And for this circuit we have to find trans resistance gain. Okay, magnitude of the trans resistance gain. It will be very easy to solve. It is again a negative feedback op amp circuit, so you can apply first of all virtual short circuit property. Name this node as A, this node I will name as B. Okay, first of all through virtual short circuit we will get VA equal to 0. Okay, virtual short circuit, V minus equal to V plus, VA equal to 0, or we can say node A is virtually grounded. Node A is virtually grounded. Next, apply KCL. Let me consider here some currents I1. Okay, this you can call I2, and here we can show I3. These currents we can show in any direction. Current in a resistor we can show in any direction, it doesn't matter. Finally answer will be same. Here I have shown all the currents flowing into node B. आप currents को आप कोई भी direction में दिखा सकते हैं. Current in a resistor can be shown in any direction. A resistor is a bilateral element. It can allow current in both directions. So when you show current in a resistor, आप उसको कोई भी डायरेक्शन में दिखा सकते हैं, उससे फर्क नहीं पड़ेगा. फाइनली जब आप आंसर फाइंड करेंगे वो सेम आएगा. ओके, मैंने यहाँ पर करंट्स को इस तरह से दिखाया है, फ्लोइंग इनटू नोड बी. नाउ अप्लाई KCL at A. KCL at node A. We will get II equal to I1 or I1 equal to II. Okay, I1 equal to II. Now I1 can be written as 0 minus VB divided by 50K. 0 minus VB divided by 50K. Remember I have taken resistor in kilo ohm. This is equal to II. या फिर हम यहाँ से लिख देंगे VB equal to minus 50 into II. Okay, VB हमने कैलकुलेट किया in terms of input current, minus 50 into input current. If one KCL does not give you the answer, apply another KCL. अब हम एक और KCL अप्लाई करेंगे. Second KCL I will apply at node B. Okay, I1 plus I2 plus I3 equal to 0. KCL at node B. I1 plus I2 plus I3 is equal to 0. अब आप I1 के प्लेस में लिख दो II, I1 same as II plus I2. What will be I2? V0 minus VB divided by 60K. V0 minus VB divided by 60 plus I3 0 minus VB divided by 5. 0 minus VB divided by 5 is equal to 0. You can take LCM and simplify this. Okay, 5 and into 60, it's like, take LCM and simplify this. Is that fine? It will become, this is 60 and this is your II. Okay, I1 same as II. I2 हमने लिखा V0 minus VB divided by 60 and I3 0 minus VB divided by 5. अब आप इसको सिंप्लीफाई करके सॉल्व करिए बेटा. टेक LCM. Okay, I think we can take 60 as a LCM. 60, it will be 60 II plus V0 minus VB minus 12 VB is equal to 0. Let us rearrange it. That 60 will cancel out. 60 II plus V0 minus 13 VB. 13 into VB. अब आप VB की प्लेस में लिख दो VB how much? minus 50 into II is equal to 0. VB मैंने सब्स्टिट्यूट किया है minus 50 into II. अब आप इसको रीअरेंज करिए बेटा. ये माइनस इंटू माइनस प्लस हो जाएगा. 13 इंटू 50 प्लस 60 710 V0 प्लस 710 II is equal to 0, or we can say V0 upon II equal to minus 710 किलो ओम. दिस विल बी इन किलो ओम. हमने रेजिस्टर्स को पुट किया था किलो ओम में, तो दिस वैल्यू विल बी इन किलो ओम. माइनस 710 किलो ओम, और यू कैन से माइनस 0.71 मेगा ओम. बट वी वांट मैग्नीट्यूड. हमें यहाँ पर मैग्नीट्यूड फाइंड करना है. तो मैग्नीट्यूड ऑफ V0 अपॉन II इट विल बी 0.71 mega ohm. Okay, in this numerical type questions you should be careful with unit. They are asking you value in mega ohm, so try to find the answer in mega ohm, and we have to tell magnitude. So minus sign you can ignore. Magnitude of the trans resistance gain how much? 0.71 mega ohms. Yes, Rushil, then Manish, John, Arnab and Vivek, better just check your answer. And you can observe in all these negative feedback op-amp circuits, I am using virtual short circuit property. Then voltage divider, when two resistors are in series, we can apply voltage divider. We can use superposition formula also and KCL. This question I have done with the help of KCL. Okay, so these four techniques will help you in solving questions on negative feedback op-amp circuits. Then let us go to another question. Now this is slightly a different question. We have to calculate here V0 by Vi for the amplifier shown. If op amp has open loop gain 80, observe this part, open loop gain of the op amp given 80. Normally for ideal op amp, open loop gain is infinite. That's what we study, right? Op amp has infinite open loop gain. That is an ideal op amp, right? But here open loop gain given as 80, that 80 is a smaller value. अगर आप उसको infinity से compare करेंगे, if you compare 80 with infinity, 80 is a smaller value. So in this problem, op amp has smaller open loop gain. तो यहाँ पर virtual short circuit becomes invalid. ये वाला question आप virtual short circuit से try नहीं करेंगे. Okay, that is why I have taken up this question. There are three special cases where we should not apply virtual short circuit. If output of the op amp saturated, virtual short circuit will be invalid. If op amp has smaller open loop gain, then also virtual short circuit becomes invalid. And the third case is if there is positive feedback or no feedback, then also we should not apply virtual short circuit. So please remember these 3 points. Okay, output saturated, op amp has smaller open loop gain, और op amp having positive feedback or no feedback, तो वहां पर हम virtual short circuit का यूज नहीं करेंगे. तो this question we have to try without virtual short circuit. अब हो सकता है एग्जाम में इनिशियली आपके दिमाग में आइडिया है, अरे ये तो इन्वर्टिंग एम्पलीफायर है, इसका गेन -R2/R1 होता है, -9/1, -9, और -9 is given as option A. तो normally in the exam we tend to hurry up, right? If you see such easy question, we try to jump to the answer. But remember, in gate paper, if such a simple question comes, first read the question 2 times. Okay, deliberately they will give -9 as option A, because initially this thought comes in our mind, it is a inverting amplifier and gain will be -R2/R1. But remember, -R2/R1, that gain will come through virtual short circuit. अपने gain को derive किया होगा -R2/R1, that will come with the help of virtual short circuit. लेकिन यहाँ पर virtual short circuit will be invalid क्योंकि op amp has smaller open loop gain. So please remember this point. Smaller का मतलब let us say below 1000. अगर question में op amp का open loop gain दिया जाता है less than 1000, then avoid virtual short circuit. तो अब हम इस question को solve करेंगे through another technique. Output of the op amp, it can be written as open loop gain into voltage at plus terminal minus voltage at minus terminal. Whenever op amp has smaller open loop gain, I mean less than 1000, let us say in the question they gave open loop gain below 1000, then don't apply virtual short circuit. आप उस question को इस तरह से try करना. Okay, output of the op amp can be written as open loop gain multiplied with V plus minus V minus, voltage at plus terminal minus voltage at minus terminal. V plus यहाँ पर 0 है and V minus will be this voltage. Let us call it as VA. Okay, V minus equal to VA, and we can write VA with the help of superposition formula. V0 into 1 plus Vi into 9 divided by 1 plus 9, that is like 10. Voltage at minus terminal, it will be VA, और VA मैंने कैलकुलेट किया है थ्रू सुपरपोजिशन फॉर्मूला, V नॉट इंटू 1K प्लस VI इंटू 9 बाई 1 प्लस 9. ओके, दिस वी कैन सब्स्टिट्यूट हियर. V नॉट इज इक्वल टू AOL कितना है बेटा 80, ओपन लूप गेन ऑफ द ऑप एम्प 80, V प्लस यहाँ पर 0 है, V माइनस के प्लेस में आप लिख दो VA एंड वी विल सब्स्टिट्यूट दैट VA लेटर. इट बिकम्स माइनस 80 VA. V प्लस मैंने लिखा है 0, V प्लस यहाँ पर 0 है, प्लस टर्मिनल डायरेक्टली ग्राउंड से कनेक्टेड है, तो V प्लस विल बी 0 एंड V माइनस इक्वल टू VA. तो इट विल बिकम माइनस 80 इंटू VA, V नॉट इक्वल टू माइनस 80 इंटू VA. अब आप VA पुट करिए बेटा, V नॉट प्लस 9 VI डिवाइडेड बाई 10. You can cancel this 10 and then rearrange. Minus 8 V naught you bring here, it will become 9 V naught. V naught plus 8 V naught is equal to minus 8 into 9 minus 72 VI, or you can say V naught by VI equal to minus 72 divided by 9. You will get answer minus 8. So in this multiple choice question, the correct answer will be option D. Minus 8 is the correct answer here. Yes, I got answers from Manish, then Rushil, John, yes, Darshan. You will find all these things in my notes. Aman is saying some noise coming. If it is little bit of noise, then please tolerate better. So this question I have taken up to convey this point that when op amp has smaller open loop gain, then we should not apply virtual short circuit. Remember this point. Let us proceed to the next question. So this is another a good type of question that can come in the gate paper. Such similar question came in one of the instrumentation gate paper. Here op amp A1 A2 are ideal except op amp A1 has input offset voltage 1 millivolt. Here A1 has a input offset voltage 1 millivolt. You know, this is called imperfection. Op amp having some input offset voltage or op amp having some input current, these are called imperfections. Ideally op amp should have zero input offset voltage, लेकिन यहाँ पर क्वेश्चन में ये गिवन है कि op amp A1 has input offset voltage 1 millivolt, and if Vi equal to 0, then what are the values of V01 and V02? We have to calculate here the values of V01 and V02. Input is given as 0. When input is 0, then we will get some non-zero output, और उस output को हम कहेंगे output offset voltage. Okay, when input is 0 and still if you get some output, then that is known as output offset voltage. तो हमें यहाँ पर output offset voltage find करना है for op amp A1 A2. Now remember, in analysis input offset voltage will be imagined at plus terminal. इस point को आप याद रखिए बेटा. When you analyze op amp circuits and in the question if input offset voltage is given, then you should imagine input offset voltage always at plus terminal. Okay, तो हम input offset voltage को यहाँ पर imagine करेंगे at the plus terminal and input is given as 0. Okay, तो मैंने इस वाले सर्किट को रीड्रॉ किया है यहाँ पर input 0 and VIO we have to imagine at the plus terminal. Okay, and for A2 देयर इज नो इनपुट ऑफसेट वोल्टेज, तो वो मैंने यहाँ पर शो नहीं किया है. ओनली A1 हैज इनपुट ऑफसेट वोल्टेज 1 मिली, वो हमने यहाँ पर दिखाया है. ऑलवेज रिमेंबर, इनपुट ऑफसेट वोल्टेज को हम इमेजिन करेंगे एट प्लस टर्मिनल. ओके, दैट इज ए डिफॉल्ट. नाउ टू कैलकुलेट V01 आप KCL अप्लाई करो बेटा इस नोड पर. KCL, you can use virtual short circuit property. This is node A. VA equal to VIO 1 millivolt, and now apply KCL. और यहां पर भी आप वर्चुअल शॉर्ट सर्किट शो कर सकते हैं. दिस इज नोड B, that VB equal to 0. Okay, and now use KCL at node A. KCL at node A. What will be current in this resistor? Let us consider currents as flowing inward. Okay, there are 3 currents that can flow into this node. So 0 minus VA divided by R, plus this current will be 0 minus VA divided by R. You have to consider this current also. Okay, VB minus VA divided by R, 0 minus VA divided by R, plus current in this resistor V01 minus 0 divided by V01 minus VA, okay, divided by R is equal to 0. There are 3 currents that can flow into node A. We are using nodal approach here, nodal analysis. We can assume currents flowing into the node, right? One current coming like this, another current coming from here, and one more current coming through this resistor. इसको आप सिंप्लीफाई करिए बेटा. R यहाँ पर कैंसिल हो जाएगा. I will get V01 equal to 3 VA. That VA is 1 milli, so V01 how much? 3 millivolt. So in this problem V01 3 millivolt, या फिर हम ऐसे भी कह सकते हैं output offset voltage for A1 3 millivolt. Then what about A2? उसके लिए आप एक और KCL यहाँ अप्लाई कर लो, नोड B. KCL at node B. VA minus 0 divided by R, okay, plus VA minus 0 divided by R, plus V02 minus 0 divided by R, V02 minus 0 divided by R is equal to 0. Okay, I have used KCL here. VA minus VB divided by R plus V02 minus VB divided by R, that sum is equal to 0. तो यहाँ से हम लिख सकते हैं V02 equal to minus VA, it will be minus 1 millivolt. Okay, V02 how much? minus 1 millivolt. अब आप ऑप्शन देखिए बेटा, 3 millivolt and minus 1 millivolt you will see in option E. So in this question we can take correct answer as option E. So you can expect question on this model also. Calculate output offset voltage of the op amp. Rushil Patel, I was telling this point 2-3 times that input offset voltage will be always imagined at plus terminal. Okay, in analysis input offset voltage को हम imagine करेंगे at plus terminal. Okay, तो जब हम circuits solve करेंगे तो आप VIO को show करना at plus terminal. Okay, so please remember this point. VIO we have shown it plus terminal, and then use normal KCL approach, you will get the answer. Okay, 3 millivolt and minus 1 millivolt, that is option A will be correct here. And they can also give you question about input bias current इनपुट ऑफसेट वोल्टेज, उस तरह का क्वेश्चन भी दिया जा सकता है इन द एग्जाम. ओके, दे कैन गिव इनपुट बायस करंट एंड इनपुट ऑफसेट वोल्टेज, बोथ द वैल्यूज कैन बी गिवन एंड दे विल आस्क यू कैलकुलेट व्हाट विल बी output of the op amp. So please try this type of questions. Okay, if you want I will include one question here. Let us say we have a circuit like this. Op amp has input bias current IB. Let us take some value 1 microampere, 1 microampere, and input offset voltage, let us say 5 microvolt. Okay, and the question is find V naught. आप कुछ इस तरह का सर्किट कंसिडर करिए. This V naught, Vi, this resistor let us say 2K and this one equal to some 20. This kind of questions have come in the previous gate papers. Questions about calculation of output offset voltage. These are called imperfections, defects in the op amp. Okay, ideally these values should be 0. Okay, but in the question they may give this type of imperfections and they will ask to calculate output. तो आप ये वाला क्वेश्चन कैसे सॉल्व करेंगे? आपको इनपुट ऑफसेट वोल्टेज अस्यूम करना होगा एट प्लस टर्मिनल. इस चीज को हमेशा याद रखना. ओके, अगर क्वेश्चन में इनपुट ऑफसेट वोल्टेज गिवन है तो उसको आप इमेजिन करेंगे एट प्लस टर्मिनल. तो जब हम क्वेश्चन सॉल्व करेंगे तो इस VIO को हम यहां पर इमेजिन करेंगे. ओके, VIO को हम प्लस वाले टर्मिनल पर इमेजिन करेंगे. आई विल शो इट हियर. दिस इज VIO एंड वी कैन शो इनपुट बायस करंट ऑल्सो IB. आप IB यहां पर भी दिखा सकते हैं. समटाइम्स दे मे गिव अनइक्वल करंट्स ऑल्सो, IB1 IB2. यहां पर मैंने दोनों करंट्स को सेम क्वेश्चन में मेंशन किया है, IB1 माइक्रो. हो सकता है दे मे मेंशन IB1 IB2 डिफरेंट ऑल्सो. तो ये वाला IB1 होगा और ये वाला IB2 होगा. यहां पर बस एक ही इनपुट करंट गिवन है तो वो अंडरस्टूड है कि बोथ टर्मिनल्स हैव सेम इनपुट करंट. तो आप इनपुट बायस करंट को इस तरह से दिखा देना, दैट IB इज कॉल्ड इनपुट बायस करंट. उसके बाद क्या करेंगे? कुछ नहीं, बस KCL अप्लाई करिए. ओके, यूज वर्चुअल शॉर्ट सर्किट. दिस इज नोड A. अगर आप वर्चुअल शॉर्ट सर्किट अप्लाई करेंगे तो VA इक्वल टू VIO and that is how much 5 microvolt. Then apply KCL. Let us consider here some current I1 and current I2. You have to find here V naught if Vi equal to 0. We are calculating here output offset voltage, so input will be taken as 0. अगर हम KCL यूज करेंगे, I will get I1 plus I2 is equal to IB. KCL I1 plus I2 is equal to IB. I1 आप लिख दो 0 minus VA divided by 2K और 0 minus VIO divided by 2K. Okay, 0 minus VA divided by 2K. That VA is nothing but VIO. And what about I2? V naught minus 0 divided by 20K. V naught minus VIO divided by 20 is equal to IB. अब आप यहां पर इस चीज को ऑब्जर्व करना कि रेजिस्टर हमने किलो ओम में लिखा है तो IB का वैल्यू हम मिली एम्पियर में लिखेंगे. रेजिस्टर्स वी हैव टेकन इन किलो ओम, so current IB we should put in milliampere. Okay, microampere को हम मिली में कन्वर्ट कर लेंगे. Is that fine? You can take LCM 20, right? So it will become minus 10 VIO plus V naught minus VIO is equal to IB, or V naught equal to 11 VIO ओके, प्लस 20 इंटू आई बी, VIO आप सब्स्टिट्यूट करिए बेटा, VIO हाउ मच, 5 माइक्रोवोल्ट, 5 माइक्रोवोल्ट, उसको आप मिली वोल्ट में कन्वर्ट कर लो, 0.005 राइट, यप, प्लस 20 इंटू आई बी हम लिखेंगे मिली एम्पियर में 0.001, रेजिस्टर इज इन किलो ओम, सो आई हैव टेकन करंट इन मिली एम्पियर, मिली इंटू किलो कैंसिल हो जाएगा, और ये आपका मिली वोल्ट में है, ये वाला टर्म मिली वोल्ट में है, ये मत भूलना, ठीक है। करंट इज 1 माइक्रो, इसको मैं ठीक से लिख देता हूं, 1 माइक्रो विल बी 0.001 मिली एम्पियर, इसको आप कैलकुलेट कर लेना, ओके। 1 माइक्रो को मैंने मिली में कन्वर्ट किया है, ये वाला वैल्यू मिली में आएगा, दोनों को ऐड कर दो, यू विल गेट द आंसर। It is coming out as 20.055 millivolt. Ultimately, you will get answer like this. So be prepared for this type of questions in the gate. Okay. Question about calculation of output offset voltage. Next, let us take up another question. Fine. This is another good type of question that can come in the gate. Similar question came in one of the instrumentation gate paper. पहली चीज आप ये नोटिस करिए बेटा कि here op amp doesn't have feedback. There is no feedback here. Op amp is in open loop condition. यहाँ पर op amp is in open loop condition. In open loop condition, op amp will act like a comparator. Remember, okay? Op amp will act like a comparator. That's what it is told. Ideal comparator. This is a comparator. अगर हम op amp को यूज करते हैं without feedback, then op amp will act like a comparator. It will compare plus voltage and minus voltage, and based on that output will become either +5 or -5. अगर V plus greater than V minus है तो output will be +5. If V minus greater than V plus, output will become -5. तो यहाँ पर op amp एक comparator की तरह काम करेगा. Okay. In this question there is no feedback. There is no negative feedback or positive feedback here. It is like op amp without feedback. So everybody should remember this point. Op amp without feedback will behave like a comparator, voltage comparator. It will compare V plus and V minus. What will be V minus here बेटा? अगर आप V minus लिखेंगे तो वो 5 into 400 divided by 600 plus 400. मैं यहाँ पे लिख देता हूँ. V minus is equal to voltage divider. Okay, 5 volt into 400 divided by 600 plus 400. इसको आप कैलकुलेट करिए. 5 into 4 divided by 10 to 2 volt, right? 5 into 4 divided by 10, 2 volt. V minus is 2 volt here. And what about V plus? V plus will be the voltage across capacitor. जो voltage capacitor के across होगा वही V plus की तरह काम करेगा. V plus is equal to Vc. Okay, V plus will be same as the voltage across capacitor, and that capacitor voltage is going to compare with 2 volt. V minus यहाँ पर 2 है and V plus is equal to capacitor voltage. So capacitor voltage will compare with 2 volt. If capacitor voltage greater than 2, output will be plus 5. If capacitor voltage becomes less than 2, output will become minus 5. अब क्वेश्चन में हमसे ये कहा गया है कि switch, there is a switch here and that switch is initially closed. Initially switch is in closed condition and switch is opened at t equal to 0. At t equal to 0, switch is opened and then it remains open after that. Then we have to find time in millisecond at which output voltage becomes low. We need to find out the time at which output becomes low. यहाँ पर low का मतलब है output becoming minus 5. तो हम क्वेश्चन को दो केसेस में एनालाइज करेंगे, बिफोर t इक्वल टू 0 एंड आफ्टर t इक्वल टू 0. ओके, बिफोर t इक्वल टू 0 स्विच इज क्लोज्ड. ओके, तो वो मैंने दिखाया है इन द नेक्स्ट स्लाइड. फॉर t लेस देन 0 स्विच इज क्लोज्ड. ओके, स्विच को मैंने शो किया है, स्विच क्लोज्ड हियर. एंड कैपेसिटर को मैंने शो किया है एज ओपन सर्किट. हमने यहां पर यह माना है कि बिफोर t इक्वल टू 0 कैपेसिटर वाज इन स्टेडी स्टेट. आई मीन स्विच वाज इनिशियली क्लोज्ड, राइट, एंड वी डोंट नो फॉर हाउ लॉन्ग स्विच वाज क्लोज्ड. तो हम ये मान के चलेंगे कि कैपेसिटर इज इन स्टेडी स्टेट. एंड यू नो फ्रॉम नेटवर्क्स, कैपेसिटर इन स्टेडी स्टेट विल बिहेव लाइक ए ओपन सर्किट. ओके, बिफोर t इक्वल टू 0 कैपेसिटर वाज इन स्टेडी स्टेट, यानी कि ओपन सर्किट. तो कैपेसिटर को मैंने शो किया है ओपन. ओके, एक्चुअली यहां पर होगा ये कि बिफोर t इक्वल टू 0 करंट विल फ्लो थ्रू 1K एंड some part of that current goes into capacitor and some current may go into 5K also and capacitor will charge. Okay, जब current flow करेगा इस तरह से then capacitor will charge. अब हमें यहाँ पर ये फाइंड करना है कि what is initial capacitor voltage before t equal to 0, what is the initial capacitor voltage. तो उसके लिए हमने कैपेसिटर को दिखाया है एज ओपन, क्योंकि इनिशियली कैपेसिटर वाज इन स्टेडी स्टेट यानी कि ओपन सर्किट. तो अब आप यहाँ का V प्लस फाइंड करिए. V प्लस विल बी सेम एज VC. इट विल बी 5 इंटू 5 डिवाइडेड बाई 1 प्लस 5. V माइनस वो मैंने ऑलरेडी लिख दिया था पिछली वाली स्लाइड में, 2 वोल्ट. V प्लस इज इक्वल टू VC एंड दैट विल बी 5 वोल्ट इंटू 5K डिवाइडेड बाई 1 प्लस 5. इट विल बी 25 वोल्ट डिवाइडेड बाई 6. ओके, दिस इज योर V प्लस. 25 डिवाइडेड बाई 6. अगर आप 25 डिवाइडेड बाई 6 कैलकुलेट करेंगे तो इट विल बी 4.166. 4.166. और आप क्लियरली देख सकते हैं V प्लस ग्रेटर देन V माइनस. सो व्हाट विल बी आउटपुट? आउटपुट विल बी हाई, आई मीन प्लस 5 वोल्ट. I mean initially output of the op amp is plus 5. Okay, so this is the analysis before t equal to 0. Then let us proceed to t equal to 0. At t equal to 0 switch is closed. Okay, at t equal to 0 switch is opened. तो वो मैंने शो किया है in the next slide. At t equal to 0 switch is opened. Okay, I have shown switch as open here. And now what will happen? Initially capacitor voltage was 25 divided by 6. Initially capacitor voltage कितना था बेटा? 25 divided by 6. Okay, and what will happen now is capacitor will start discharging. Now capacitor will start discharging. capacitor इस तरह से discharge करेगा. Okay, it will discharge through 5K and when a capacitor is discharging, capacitor voltage will decrease. और कैपेसिटर का वोल्टेज कहां तक डिक्रीज करेगा? आई मीन इट विल डिक्रीज ग्रेजुअली अप टू 0, नो डाउट, बट व्हेन इट बिकम्स स्लाइटली लेस देन 2 वोल्ट, व्हेन दिस VC बिकम्स स्लाइटली लेस देन 2 वोल्ट, देन आउटपुट विल चेंज टू -5. तो हमें यहां पर ये फाइंड करना होगा कि एट व्हाट टाइम कैपेसिटर वोल्टेज बिकम्स 2. व्हेन VC बिकम्स स्लाइटली लेस देन 2, देन आउटपुट विल बिकम -5. आई मीन आउटपुट विल बिकम लो. तो अब आप ये फाइंड करो कि एट व्हाट टाइम कैपेसिटर वोल्टेज इज गोइंग टू बिकम 2 वोल्ट. फर्स्ट ऑफ ऑल कैपेसिटर इज डिस्चार्जिंग हियर. थ्रू 5K. Okay, and we can find out expression for capacitor voltage Vc equal to, you know the expression how to write voltage across capacitor in transient state. Okay, now capacitor will be in transient state, तो capacitor का voltage हम लिखेंगे V final plus V initial minus V final into e to the power minus t by RC. That R into C is called time constant. And how much is R into C here? अगर आप मल्टीप्लाई करेंगे 5K into 0.1 माइक्रोफैरेड, it will become 0.5 millisecond. Time constant is 0.5 millisecond here. Vc equal to V final will be 0 here. Capacitor will discharge up to 0 volt, right? So what will be V final? 0 volt. In transient analysis, V final का मतलब होता है voltage at t equal to infinity. Yes, and you know well, at t equal to infinity capacitor will be fully discharged and Vc will become 0. या फिर आप ऐसे भी सोच सकते हैं, at t equal to infinity again capacitor will become open. If capacitor open, then there will be no current in 5K and this voltage will become 0. या फिर आप डायरेक्टली कह सकते हैं कैपेसिटर इज डिस्चार्जिंग थ्रू रेजिस्टर, तो उसका V फाइनल कितना होगा? 0 वोल्ट होगा. कैपेसिटर विल डिस्चार्ज अप टू 0, तो V फाइनल हम लिख देंगे 0. V इनिशियल कितना है बेटा? 25 डिवाइडेड बाई 6 माइनस 0 इंटू ई पावर माइनस t by RC. And now you put Vc equal to 2 volt. Put Vc 2 volt. Remember, if Vc becomes slightly less than 2, then output will become minus 5. तो हमें उस टाइम को फाइंड करना होगा at which Vc becoming 2 volt. तो put Vc 2 volt and t equal to let us say t1. 2 is equal to 25 divided by 6 into e power minus t1 by RC. अब आप यहाँ से t1 फाइंड करिए बेटा, इसको थोड़ा रीअरेंज कर लेना. e power t1 by RC is equal to 25 divided by 12. Okay, take natural log, take ln, so this will become t1 equal to RC into ln 25 डिवाइडेड बाई 12. इसको आप कैलकुलेट करिए बेटा. R इंटू सी 0.5 मिली सेकेंड है, 0.5 मिली सेकेंड इंटू ln 25 बाई 12. ln 25 डिवाइडेड बाई 12 मल्टीप्लाइड बाई 0.5, 0.367. I am getting a value 0.367 milliseconds. I mean, at this time output of the op amp will change from high to low. Okay, output of the op amp will change from plus 5 to minus 5 at this time, 0.367 millisecond. So in this question which is an I think numerical data type question, तो इसका आंसर होगा 0.367 milliseconds. So be prepared for this type of questions also. Here op amp was in open loop condition. They can give op amp with positive feedback also, and there will be some switch. Such questions have come in the gate papers of all branches, electronics, electrical and even instrumentation gate paper. Okay, इस वाले question में op amp was not having feedback, but they can give question where op amp will have positive feedback also. तो आप इसको इस तरह से analyze कर सकते हैं. Before t equal to 0, after t equal to 0. तो आप सर्किट को दो केसेस में एनालाइज करना, बिफोर t इक्वल टू 0 एंड आफ्टर t इक्वल टू 0. यस, मनीष, अर्श, इशिता, यस बेटा, आंसर इज 0.367 milliseconds. Then let us go to next question. Now this is another important type of question that can come in the gate paper. Such questions have come in electrical gate paper and also instrumentation gate papers. And here the question says, the figure shows an oscillator having ideal Schmidt trigger and its input output characteristics, these are called transfer characteristics, okay, V0 versus Vi, these are transfer characteristics of Schmidt trigger, okay. That 3 volt will be called upper threshold voltage, 1.5 volt is called lower threshold voltage, okay, and output changing between 0 volt and 5 volt, this you take as 0. Output of this circuit changing between 0 volt and 5 volt, and 3 volt is a upper threshold and 1.5 volt is a lower threshold voltage, and this block is a Schmidt trigger. अगर आप इसका एक्चुअल सर्किट देखना चाहते हैं, आई मीन हाउ दिस Schmidt ट्रिगर विल बी, तो वो मैंने शो किया है इन द नेक्स्ट स्लाइड. दिस इज एक्चुअली एन एस्टेबल मल्टीवाइब्रेटर. इस तरह के सर्किट को हम कहते हैं एस्टेबल मल्टीवाइब्रेटर. अगर आप Schmidt ट्रिगर में एक रेजिस्टर कैपेसिटर कनेक्ट कर दें एज ए एक्स्ट्रा एलिमेंट, इट विल बिकम एस्टेबल मल्टीवाइब्रेटर, ओके. इन द बेसिक Schmidt ट्रिगर, इफ यू ऐड वन रेजिस्टर एंड कैपेसिटर, इट विल बिकम एन एस्टेबल मल्टीवाइब्रेटर. So this actually an astable multivibrator, it will give you square wave output, okay. अब हमें यहाँ पर टाइम पीरियड फाइंड करना है इन मिली सेकेंड. आपकी अंडरस्टैंडिंग के लिए मैंने इसका सर्किट ड्रॉ किया है. यहाँ पर ये जो येलो पार्ट मैंने दिखाया है, येलो कलर, दैट इज योर Schmidt trigger, okay. That op amp and this resistors, let us say R1 R2, some R1 R2, okay. This is your Schmidt trigger. In that Schmidt trigger, if you connect one resistor capacitor also, then it will become an astable multivibrator. It will give you square wave output. Output को मैंने यहाँ पर ड्रॉ किया है. This is the output. Output is a square wave. It will change between 0 volt and 5 volt. Okay. इस interval को मैंने assume किया है T1 and this interval I have assumed as T2. That T1 plus T2 will become time period. And in this circuit, capacitor will charge and discharge. When output is plus 5, capacitor will charge, okay. When output is plus 5 volt, capacitor will charge. Op amp will provide the charging current. Current ऐसे flow करेगा, it will flow from output terminal of the op amp into resistor and then into capacitor. So whenever output plus 5, capacitor will charge. तो उसको मैंने यहाँ पर शो किया है. This is your waveform for capacitor. Capacitor will charge from lower threshold to upper threshold, and when output becomes 0, then capacitor will discharge through this resistor, okay. And that discharging current will flow through capacitor, through resistor, and then it goes into output terminal of the op amp. So this is the basic operation of astable multivibrator. When output plus 5, capacitor will charge through the resistor, and when output becomes 0, capacitor will discharge through this resistor, okay. And in that way, capacitor voltage will increase and decrease exponentially. When charging happens, capacitor voltage will increase exponentially, and when capacitor discharges, capacitor voltage will decrease exponentially. तो ये बेसिक आइडिया आपके दिमाग में होना चाहिए, तभी आप इस तरह का क्वेश्चन सॉल्व कर सकते हैं, ओके. टू सॉल्व दिस टाइप ऑफ क्वेश्चन, यू नीड टू नो दिस वेव फॉर्म, ओके. आपको इसका आइडिया होना चाहिए कि हाउ एन एस्टेबल मल्टीवाइब्रेटर विल वर्क. आउटपुट स्क्वायर वेव होगा एंड कैपेसिटर वोल्टेज विल बी एन एक्सपोनेंशियल वेव फॉर्म, एक्सपोनेंशियल इंक्रीज एंड एक्सपोनेंशियल डिक्रीज, एंड कैपेसिटर वोल्टेज वेरीज बिटवीन लोअर थ्रेशोल्ड एंड अपर थ्रेशोल्ड. अब हम ये इंटरवल्स फाइंड करेंगे T1 एंड T2, ओके. लेट अस फर्स्ट कैलकुलेट T1. Consider T1 interval, okay. In this interval, capacitor will charge. Capacitor ऐसे चार्ज करेगा, capacitor charges, okay. And we will now find expression for capacitor voltage. Vc equal to, you know the formula, V final plus V initial minus V final into e to the power minus t by r into c. That r into c is called time constant. अगर आप टाइम कांस्टेंट फाइंड करेंगे 10 किलो ओम इंटू 1 माइक्रोफैरेड, इट विल बी 10 मिलीसेकेंड. 10 milliseconds. Now what will be V initial and V final? In the T1 interval, initial voltage will be 1.5. Okay, V initial यहाँ पर 1.5 होगा. And what will be V final? अब यहाँ पर बहुत सारे बच्चे कंफ्यूज हो जाते हैं. They think कि V final 3 वोल्ट है. It is wrong. V final का मतलब होता है voltage at t equal to infinity. Please remember, V final means voltage at t equal to infinity. और आपको अच्छे से पता है फ्रॉम नेटवर्क्स एट t equal to infinity कैपेसिटर बिकम्स ओपन सर्किट. तो आपको V फाइनल डिसाइड करना होगा बाय टेकिंग कैपेसिटर एज ओपन सर्किट. तो अगर आप कैपेसिटर को ओपन मानेंगे तो यहाँ पर कितना वोल्टेज अपीयर करेगा? 5 वोल्ट. आपका आउटपुट 5 है तो वो 5 वोल्ट यहाँ अपीयर करेगा. ओके, या फिर हम ऐसे भी कह सकते हैं V फाइनल मीन्स स्टेडी स्टेट वोल्टेज, वोल्टेज अक्रॉस कैपेसिटर इन स्टेडी स्टेट. इन स्टेडी स्टेट capacitor will behave like open circuit. So whenever you find V final, you should take capacitor as open circuit. और जब हम इंडक्टर की बात करते हैं, in case of इंडक्टर we deal with current, right? वहां पर हम लिखेंगे final current, V I final. In steady state, inductor is a short circuit. At t equal to infinity, capacitor will be open circuit and inductor will be short circuit. तो ये आपको अच्छे से पता है from networks, okay? तो जब आप V फाइनल लिखेंगे यू शुड टेक कैपेसिटर एज ओपन सर्किट. तो अगर हम कैपेसिटर को ओपन मानेंगे तो आपका आउटपुट 5 वोल्ट है, वो यहां पर अपीयर करेगा 5 वोल्ट. तो आप V फाइनल लिखिए बेटा 5 वोल्ट प्लस V इनिशियल कितना है 1.5 माइनस 5 इंटू ई टू दी पावर माइनस टी बाई आर सी. तो इन दिस वे यू विल गेट एक्सप्रेशन फॉर कैपेसिटर वोल्टेज. Now we want to know T1. At the end of T1 interval, capacitor voltage how much? 3 volt. तो अब आप ये करिए कि T की प्लेस में लिख दो T1 and put VC as 3 volt. Okay. At the end of T1 interval, capacitor voltage becomes how much? 3. So you put T equal to T1 and VC equal to 3. Put T equal to T1 and Vc equal to 3 volt. So this will become 3 equal to 5 minus 3.5. Okay, 1.5 minus 5 it will become minus 3.5 into e power minus t1 by rc. इसको आप थोड़ा सिंप्लीफाई करना बेटा. 3.5 into e power minus t1 by rc is equal to 5 minus 3. What will be 5 minus 3? 2. Okay, 2 volt. मैंने थोड़ा शफलिंग किया है. 3.5 into this exponential is equal to 5 minus 3. इसको आप और भी सिंप्लीफाई करिए. e to the power t1 by rc is equal to 3.5 divided by 2 and then take natural log. t1 equal to rc into ln 3.5 डिवाइडेड बाई 2. तो यहां से आप T1 कैलकुलेट करना. R इंटू सी 10 मिली सेकेंड है. R इंटू सी इज कॉल्ड टाइम कॉन्स्टेंट, इट इज 10 मिली सेकेंड मल्टीप्लाइड बाई ln 3.5 by 2. I'm getting it as 5.596 milliseconds. Hope everybody able to get the same answer. तो इस तरह से हमने T1 कैलकुलेट किया है. Then you should calculate T2 also. Please reply through comment कि everybody getting the same value for T1. Yes, Chandan. 5.596 मिलीसेकेंड इज T1. नेक्स्ट हम T2 फाइंड करेंगे. अब हमें T2 फाइंड करना होगा. ओके, T2 इज द इंटरवल ऑफ दैट नेगेटिव साइकिल. Okay, let us now calculate T2. Consider T2 interval. Now in T2 interval, capacitor will discharge. Capacitor discharges. Is that okay? In the T2 interval, output becomes 0. So capacitor will discharge. Capacitor ऐसे discharge करेगा. Okay? Capacitor will discharge through same resistor. And now what will be V initial and V final? Okay? For the T2 interval, V initial will be 3 volt. And what will be V final? 0. I repeat again, V final का मतलब होता है voltage at t equal to infinity. So we have to take V final as 0 here. Vc equal to V final plus V initial minus V final into e power minus t by RC. V final आप लिख दो 0, V initial you can put 3 minus 0 into e power minus t by RC. Okay, for the T2 interval, initial voltage is 3 volt and V final we should take as 0. Okay, I mean at t equal to infinity, capacitor will be in fully discharged condition and its voltage will be 0. And now apply the condition. अब आप क्या condition apply करेंगे? T equal to T2 and Vc equal to 1.5. At the end of T2 interval, capacitor voltage becomes 1.5. तो आप condition put करिए T equal to T2 and Vc equal to 1.5. Put T equal to T2 and Vc equal to 1.5 volt. So it will become 1.5 equal to 3 into e power minus T2 divided by RC. इसको आप थोड़ा सिंप्लीफाई कर लेना. You will get T2 equal to RC into ln 3 by 1.5. Okay, please do rearrangement. You will get T2 in this way. R into C 10 मिलीसेकेंड है into ln2 लगभग 0.69 के बराबर होता है, राइट? लेट मी यूज एग्जैक्ट वैल्यू. ln2 0.693 into 10, 6.931. I am getting it as 6.931 millisecond. Now calculate time period. It will be T1 plus T2. अब T1 T2 ऐड करिए बेटा. T1 is 6.931 and what was T1? 5.596. 12.527. I am getting a value 12.527 milliseconds. 12.527 milliseconds. So in this numerical data type question, we have to answer time period up to 3 decimal places. So it will be 12.527 milliseconds. रोहित इज आस्किंग कि गेट ईसीई के लिए बीजेटी वाला टॉपिक स्किप कर सकते हैं. मत करना बेटा ऐसी मिस्टेक. बीजेटी को पढ़ना ही है, ठीक है? यू नेवर नो व्हेन द गेट विल सरप्राइज यू. सो इलेक्ट्रॉनिक स्टूडेंट्स प्लीज प्रिपेयर बीजेटी टॉपिक ऑल्सो. ओके, उसको छोड़ के मत जाना. पिछले 2 साल से क्वेश्चन नहीं पूछा है बीजेटी से, उसका मतलब ये नहीं कि दे विल नॉट आस्क क्वेश्चन फ्रॉम बीजेटी. ओके, बीजेटी से भी क्वेश्चन आ सकता है इन द गेट पेपर, तो पढ़ के जाना. ये 4 टॉपिक्स मेजर हैं: डायोड, बीजेटी, मॉसफेट, ऑप एम्प. इसको अच्छे से प्रिपेयर करना. ओके, ऑप एम्प इलेक्ट्रॉनिक्स बैच के लिए सबसे पहले मॉसफेट आएगा, देन कम्स ऑप एम्प, देन कम्स डायोड एंड देन बीजेटी. एंड फॉर इलेक्ट्रिकल बैच सबसे पहले आता है आपका ऑप एम्प, देन डायोड, देन बीजेटी एंड देन मॉसफेट. दैट इज द ऑर्डर. तो ये 4 टॉपिक्स अच्छे से प्रिपेयर करके जाइए. ओके, So this was one question about astable multivibrator. So in this op-amp I have covered negative feedback op-amp circuits, open loop, some imperfections in the op-amp, and also positive feedback op-amp. This astable multivibrator, it is an example for positive feedback op-amp. In positive feedback op-amp circuit there are three important circuits. एक हो गया आपका Schmitt trigger अच्छे से पढ़ के जाना, right? Then astable multivibrator and triangular wave generator. These three circuits come under positive feedback op-amp applications and they are quite important for the gate paper. Schmitt trigger, astable multivibrator and triangular wave generator. Then negative feedback op-amp circuits, वहाँ पर आप पहले तो बेसिक एप्लीकेशंस प्रिपेयर करिए, इन्वर्टिंग एम्पलीफायर, नॉन इन्वर्टिंग एम्पलीफायर, वोल्टेज फॉलोवर, डिफरेंस एम्पलीफायर, ओके. देन यू हैव सम अदर एप्लीकेशंस लाइक देयर आर कन्वर्टर्स, V to I converter, I to V converter, right? Log amplifier, anti log amplifier, integrator, differentiator, okay. We have प्रेसिशन हाफ वेव रेक्टिफायर, वो भी इंपॉर्टेंट है, वो भी प्रिपेयर करके जाना, राइट. देन फिल्टर्स, एक्टिव फिल्टर्स, लो पास फिल्टर, हाई पास फिल्टर, बैंड पास फिल्टर. एक्टिव फिल्टर्स आर आल्सो इंपॉर्टेंट इन नेगेटिव फीडबैक ऑप एम्प सर्किट्स. एंड यू शुड रिमेंबर द कंडीशंस व्हेन वर्चुअल शॉर्ट सर्किट इनवैलिड, ओके. एंड यू शुड नो हाउ टू डील विथ imperfections in the op amp. If op amp has input current or op amp has input offset voltage, then how to calculate the output. So these are the major areas from op amp topic, okay. Let us go to another question. Fine, this is a question about filter. इसको हम कहते हैं Sallen key filter. It is a second order low pass filter, okay. You can see here low pass RC. This is actually a low pass RC, right? So this is basically a second order लो पास फिल्टर. इसको हम Sallen की फिल्टर भी कह सकते हैं, Sallen की फिल्टर, राइट. एंड हमें यहाँ पर इसका फ्रीक्वेंसी रिस्पॉन्स डिसाइड करना है एंड दोज ऑप्शंस आर देयर इन द नेक्स्ट स्लाइड. दीज आर द 4 ऑप्शंस, ओके. यू हैव टू टेल which option is correct, okay. So active filter is also an important area for all the branches, electronics, electrical and also instrumentation gate paper. Active filter an important area, okay. तो इस क्वेश्चन में आपको ये बताना है कि विच ग्राफ रिप्रेजेंट्स फ्रीक्वेंसी रिस्पॉन्स, ओके. पहले सर्किट देख लेते हैं. इट इज अ लो पास फिल्टर, सेकेंड ऑर्डर लो पास फिल्टर. दिस इज ए सेकेंड ऑर्डर LPF लो पास फिल्टर. इसको हम Sallen की फिल्टर भी कह सकते हैं, Sallen की फिल्टर. इसके लिए पहले आप कट ऑफ फ्रीक्वेंसी फाइंड करो और 3 dB फ्रीक्वेंसी. रेजिस्टर्स आर इक्वल एंड कैपेसिटर्स आल्सो आइडेंटिकल. तो इसका फॉर्मूला होता है, सबको पता होना चाहिए. इफ RC एलिमेंट्स आर आइडेंटिकल देन व्हाट इज द फॉर्मूला फॉर कट ऑफ फ्रीक्वेंसी? FC इक्वल टू 1/2 pi R into C. If this RC elements identical then cut off frequency will be 1/2 pi R into C. अगर RC एलिमेंट्स नॉन आइडेंटिकल हो तो फॉर्मूला कुछ इस तरह से लिखते हैं 1/2 pi इंटू अंडर रूट RX RY इंटू CX CY. I mean let us say capacitor CX and CY and resistors are RX and RY. अगर RC एलिमेंट्स नॉन आइडेंटिकल हो तो आप ये वाला फॉर्मूला यूज करना. लेकिन यहाँ पर RC एलिमेंट्स आइडेंटिकल है तो हम FC को इस तरह से फाइंड करेंगे, कट ऑफ फ्रीक्वेंसी और 3 dB फ्रीक्वेंसी. R यहाँ पर 22 किलो ओम्स है एंड कैपेसिटर हाउ मच 330 पिकोफैरेड. तो बेटा आप यहाँ से पहले कट ऑफ फ्रीक्वेंसी फाइंड कर लो. 2 पाई मल्टीप्लाइड बाई रेजिस्टर हाउ मच 22 किलो ओम्स इनटू कैपेसिटर हाउ मच 330 पिकोफैरेड. I'm getting a value 21.92 kilohertz. 21.92 kilohertz. Then you should find maximum gain in decibel. For this filter, maximum gain it will be 1 plus R2 by R1. Okay, this is your R1 and this is your R2. For this filter, maximum gain will be 1 plus R2 by R1. We call it a non-inverting type filter. Input हमने अप्लाई किया है towards non-inverting terminal. It is a non-inverting type filter. तो इसका maximum gain होगा 1 plus R2 by R1. Okay, 1 plus R2 by R1. 1 plus 10 by 17. .588. I'm getting a value 1.588. इसको आप dB में कन्वर्ट करिए बेटा. A max in decibel 20 into log to the base 10 1.588. It is log to the base 10 multiplied by 20. I am getting a value 4 dB, approximately 4 decibel. 4 dB. So in this filter, it is a low pass filter. Remember, in this low pass filter you have cutoff frequency 21.9 kilohertz and maximum gain in dB 4 dB. 4 dB. अब आप ऑप्शंस देखिए बेटा, लुक एट दी ऑप्शंस. अगर आप ऑप्शंस देखेंगे तो A and C मैक्सिमम गेन 4 dB एंड कट ऑफ फ्रीक्वेंसी 21.9 किलोहर्ट्ज. बट हमें यहाँ पर एक और चीज याद रखनी होगी कि इट इज ए सेकेंड ऑर्डर फिल्टर. फॉर सेकेंड ऑर्डर फिल्टर व्हाट विल बी रोल ऑफ रेट 40 dB पर डेकेड. ये आपको पता होना चाहिए. फर्स्ट ऑर्डर फिल्टर रोल ऑफ रेट 20 dB per decade, and for second order filter roll off rate how much 40 dB per decade. Okay, so that point should also be remembered. Roll off rate, we call it a roll off rate. I mean the rate at which gain decreases outside pass band. The rate at which gain decreases outside pass band is known as roll off rate. सेकेंड ऑर्डर फिल्टर का मतलब है ए सिस्टम हैविंग टू पोल्स. इसको आप कंट्रोल से भी रिलेट कर सकते हैं, कंट्रोल सिस्टम्स. इफ ए सिस्टम हैज वन पोल देन गेन डिक्रीजेस एट व्हाट रेट 20 dB per decade. If a system has two poles gain decreases at 40 dB per decade. तो यहाँ पर roll off rate will be 40 decibel per decade. Decade का मतलब फ्रीक्वेंसी इंक्रीज बाय 10 टाइम्स. अगर आप फ्रीक्वेंसी को 10 टाइम्स इंक्रीज करेंगे देन गेन विल डिक्रीज बाय 40 डेसिबल. तो ये पॉइंट आप याद रखिए. इसका जनरल फॉर्मूला भी होता है इफ देयर इज ए nth ऑर्डर फिल्टर देन रोल ऑफ रेट हाउ मच 20 into n. इफ n equal to 1 it will be 20 dB, n equal to 2 40 dB, n equal to 3 60 dB. उस तरह से. ओके, अब आप बताइए कौन सा ऑप्शन सही होगा. आई थिंक ऑप्शन सी शुड बी करेक्ट, राइट. मैक्सिमम गेन 4 dB, कट ऑफ फ्रीक्वेंसी 21.9 किलोहर्ट्ज एंड इसको हम कहते हैं रोल ऑफ रेट. रेट एट विच गेन इज डिक्रीजिंग, वो 40 dB पर डेकेड होगा और यहाँ पर 20 dB है, ये गलत होगा, राइट. तो करेक्ट आंसर इज ऑप्शन सी. चंदन बेटा डबल ई के लिए इलेक्ट्रिकल स्टूडेंट्स बीजेटी भी पढ़ के जाना. डायोड, बीजेटी, ऑप एम्प, यहां से ज्यादा क्वेश्चंस पूछे जाते हैं फॉर इलेक्ट्रिकल. डायोड, ऑप एम्प एंड बीजेटी. तो ये तीन तो पक्के आने चाहिए, राइट, फॉर इलेक्ट्रिकल स्टूडेंट्स. इसके साथ साथ थोड़ा मॉसफेट का भी बेसिक आइडिया दिमाग में रख लो. फॉर इलेक्ट्रिकल स्टूडेंट्स मॉसफेट से इजी क्वेश्चंस आएंगे. अगर क्वेश्चन कम फ्रॉम मॉसफेट इट विल बी इजी टू आंसर फॉर इलेक्ट्रिकल बैच. लेकिन इलेक्ट्रॉनिक्स में वो अपोजिट है. इलेक्ट्रॉनिक्स में मॉसफेट के तगड़े क्वेश्चन पूछे जाएंगे. ओके, आप पिछले 10 साल के क्वेश्चन देखिए. इलेक्ट्रॉनिक्स बैच मॉसफेट दे आर आस्किंग सो मेनी गुड क्वालिटी क्वेश्चंस फ्रॉम मॉसफेट. इलेक्ट्रिकल बैच के लिए मैं कहूंगा मॉसफेट का थोड़ा बेसिक आइडिया रखिए. मॉसफेट का बायसिंग, राइट, देन कॉमन सोर्स मॉसफेट एम्पलीफायर, उसका गेन कैसे निकालते हैं, राइट, वो आपको आना चाहिए. सो दिस वर सम क्वेश्चंस बेस्ड ऑन op amps. Then we will go to active filter. मैंने हर इंपॉर्टेंट टॉपिक से एक क्वेश्चन यहाँ पर सेलेक्ट किया है ताकि आपको आइडिया मिले कि कौन से टॉपिक्स आपको प्रिपेयर करना है, राइट। हर क्वेश्चन का एक टॉपिक है, ये वाला टॉपिक है फिल्टर, एक्टिव फिल्टर, तो फिल्टर्स को भूलना मत, राइट। लो पास फिल्टर, हाई पास फिल्टर अच्छे से पढ़ के जाना। लेट अस गो टू some more questions. Now these are questions based on MOSFETs. After op amp I will take up some questions on MOSFETs. Everybody read this question. Let us try this question now. This type of question can come for both electronics as well as electrical batch. Okay, there are two things in the amplifier shown. MOSFET has mu p cox into W by L 1 milliampere per volt square. It is a PMOS, P channel MOSFET. You can look at the arrow inward, arrow pointing inward. It is a P channel MOSFET. Okay, this terminal will be source, this will be drain, and here is gate. Okay, it is a P channel MOSFET. We have to find out, it has a threshold voltage minus 0.5, that Vt is nothing but threshold minus 0.5 volt, and we have to find drain current lambda equal to 0. The lambda is called channel length modulation parameter. Mostly in the gate paper they will give lambda 0, yani ki there is no channel length modulation effect. Lambda is called channel length modulation parameter. You have to find out DC drain current, DC drain current. Okay, first of all, for DC analysis capacitors will be open. Remember this point, whether it is a BJT or MOSFET amplifier. If you are doing DC analysis, DC calculation, there you will take capacitors as open. And calculate gate voltage. पहले आप गेट का वोल्टेज फाइंड करिए बेटा। आप सुपरपोजिशन फॉर्मूला यूज कर सकते हैं। R1 R2 यहाँ पर सीरीज में है। गेट करंट इन ए MOSFET इज 0, राइट। फॉर ए MOSFET गेट करंट ऑलवेज 0, यानी कि करंट फ्लोइंग इनटू गेट विल बी 0। तो जो करंट R1 में फ्लो करेगा वही करंट R2 में भी फ्लो करेगा। तो हम ये कह सकते हैं कि R1 R2 आर इन सीरीज। सो वी कैन कैलकुलेट गेट वोल्टेज थ्रू सुपरपोजिशन फार्मूला। सुपरपोजिशन फार्मूला -5 into 200 plus 5 into 300 divided by 200 plus 300. Okay, I have used superposition formula. -5 into 200 plus 5 into 300 divided by 200 plus 300. तो यहां से आप गेट वोल्टेज फाइंड करिए। Vg इक्वल टू 0 0 आप कैंसिल कर दो, ये हो गया 15 minus 10 5 divided by 5 it will be 1 volt. Gate voltage 1 volt. Then for P channel MOSFET आप वोल्टेज दिखाइए यहाँ पर VSG, वोल्टेज बिटवीन सोर्स एंड गेट। PMOS के लिए हम शो करेंगे VSG, NMOS के लिए हम शो करेंगे VGS, गेट टू सोर्स वोल्टेज। इन PMOS we will show सोर्स टू गेट वोल्टेज VSG। VSG का मतलब होता है सोर्स वोल्टेज माइनस गेट वोल्टेज। यू कैन शो हियर करंट इन PMOS, करंट विल फ्लो फ्रॉम सोर्स टू ड्रेन। इन P चैनल MOSFET करंट फ्लोज फ्रॉम सोर्स टू ड्रेन, तो करंट को हम लिख देंगे ISD। NMOS के लिए हम करंट लिखेंगे IDS। इन NMOS करंट फ्लोज फ्रॉम ड्रेन टू सोर्स। P चैनल MOSFET करंट फ्लोज फ्रॉम सोर्स टू ड्रेन। ISD. Okay, so what will be source voltage beta? Source voltage will be 5 volt minus 2 ISD. And gate voltage how much? 1. Okay, source voltage I have written 5 volt minus this drop 5 minus 2 ISD, and gate voltage how much? 1. इसको आप थोड़ा रीअरेंज कर लो. ISD equal to, it will become 4 minus VSG divided by 2. Take it as equation 1. अब यहाँ पर दो अननोन है, करंट भी अननोन है एंड VSG का वैल्यू भी अननोन है. देयर आर टू अननोन्स. ओके, अब हम मॉसफेट का करंट इक्वेशन यूज करेंगे. अब क्वेश्चन में गिवन है एम्पलीफायर. एम्पलीफायर का मतलब होता है कि मॉसफेट शुड बी इन सैचुरेशन रीजन, एंड फॉर इलेक्ट्रिकल स्टूडेंट्स you can always consider MOSFET in saturation. Mostly they will frame question with MOSFET in saturation for electrical batch. Electronics batch saturation region या फिर वो linear region भी हो सकता है, लेकिन यहाँ पर एम्पलीफायर मेंशन है तो ये अंडरस्टूड है कि MOSFET शुड बी इन सैचुरेशन. तो अब हम MOSFET का सैचुरेशन रीजन वाला करंट इक्वेशन यूज करेंगे. ISD इक्वल टू, फॉर PMOS करंट हम ऐसे लिखते हैं म्यू पी COX by 2 into W by L into VSG minus mod VT whole square. This is the current equation for P channel MOSFET, assuming that MOSFET is in saturation region. If P channel MOSFET is in saturation region, then this will be current. Okay, अब आप ISD की प्लेस में लिख दो 4 minus VSG divided by 2 is equal to, this parameter is given 1 milliampere, 1 divided by 2 into VSG minus mod VT. What will be mod VT? 0.5 whole square. इसको आप बेटा सिंप्लीफाई करना, ये सब कर सकते हैं, राइट? यू कैन एक्सपैंड इट a minus b whole square and you write it as a quadratic equation. 2 कैंसिल हो जाएगा. 4 minus VSG is equal to a minus b whole square. It will be VSG square, okay, plus 0.25 minus VSG. Now from both the sides VSG वाला टर्म कैंसिल हो जाएगा. VSG square equal to 3.75. तो यहां से आप VSG फाइंड करिए बेटा. root of 3.75, okay, root of 3.75, it is 1.9365, 1.9365 volt. VSG equal to this much. Negative root you can discard. Root will be plus and also minus. माइनस वाला रूट आप इग्नोर करिए क्योंकि VSG should be greater than mod VT. ये कंडीशन याद रखना. A P channel MOSFET will conduct if VSG greater than mod VT. ओके, तो आप नेगेटिव वाला रूट इग्नोर करिए, कंसिडर ओनली पॉजिटिव रूट. देन कैलकुलेट करंट. हमें यहां पर करंट फाइंड करना है. ISD इक्वल टू, आप ये इक्वेशन यूज कर लो, 4 minus VSG डिवाइडेड बाई 2. 4 minus VSG कितना है बेटा? 1.9365 divided by 2. 1.032. I'm getting a value 1.032 milliampere. So this is the drain current for P channel MOSFET. I hope you have tried this question. Please let me know through comment कि आपने भी ये क्वेश्चन ट्राई किया है. This will make the session more interacting. I think op-amp के बाद MOSFET में सारा सन्नाटा छा गया है सर. I hope everybody is able to get this answer. 1.032 milliampere. Then in the same problem we have to find voltage gain also. This you take as another question. इसी question में हम voltage gain भी find करेंगे. Okay. This is actually a common source amplifier. Input हमने apply किया है at gate and output voltage taken from drain. If input node is gate, okay, if input node is gate and if output node is drain, then it will be called common source amplifier. It is a common source amplifier and unbypassed, without bypass. Okay, between source terminal and ground there is no bypass capacitor. Okay, in this amplifier between source terminal and ground you don't have bypass capacitor. तो इसको हम कहेंगे common source amplifier without bypass capacitor. जैसे कॉमन एमीटर होता है विदाउट बाईपास, सिमिलरली इसको हम कहेंगे कॉमन सोर्स एम्पलीफायर विदाउट बाईपास कैपेसिटर. अब इसके लिए या तो आप फॉर्मूला याद रखो, गेन का एक फॉर्मूला होता है -gm इंटू आर डी डिवाइडेड बाई 1 प्लस GM इंटू आर एस. अगर आपको फॉर्मूला याद हो तो आप डायरेक्टली फॉर्मूला यूज करके गेन फाइंड करना. अब कुछ बच्चों को फॉर्मूला याद रखने में दिक्कत होती है तो वो आप इसका मॉडल बना के सॉल्व कर लेना. रिप्लेस MOSFET विद स्मॉल सिग्नल मॉडल एंड ट्राई टू आंसर. ओके, मैंने इसके लिए मॉडल शो किया है इन द नेक्स्ट स्लाइड. अगर आप MOSFET को रिप्लेस करेंगे, दिस इज द स्मॉल सिग्नल मॉडल. ओके, RDS और R0 वो मैंने यहाँ पर शो नहीं किया है क्योंकि यहाँ पर लैम्डा का वैल्यू 0 है. ओके, लैम्डा यहाँ पर 0 है तो इट मीन्स R0 इन्फानाइट, या फिर आप ऐसे भी लिख सकते हैं RDS इन्फानाइट. That is why I haven't shown resistor here in parallel to current source. In small signal model we just need to show current source GM VGS. Okay, फिर source से ground के बीच में you will get RS. You know this small signal AC analysis, right? Supply nodes ground हो जाएंगे, ये वाला नोड ground हो गया, ये वाला नोड भी ground हो जाएगा. Capacitors become short circuit. In small signal AC analysis, this capacitors become short circuit and DC supplies are deactivated or disabled. Then source और ground के बीच में you will get RS, drain और ground के बीच में you will get RD. Then R1 R2 दोनों गेट और ग्राउंड के बीच में है, R2 गेट और ग्राउंड के बीच में है, और आप R1 भी देख सकते हैं बिटवीन गेट एंड ग्राउंड, यानी कि R1 R2 गेट और ग्राउंड के बीच में है, दे आर इन पैरेलल. तो वही मैंने शो किया है इन द नेक्स्ट स्लाइड. गेट और ग्राउंड के बीच में मैंने R1 R2 को पैरेलल में दिखाया है. सोर्स टू ग्राउंड यू हैव RS, बिटवीन ड्रेन एंड ग्राउंड यू हैव RD एंड दिस योर इनपुट. अब हम यहां से वोल्टेज गेन फाइंड करेंगे. पहले GM कैलकुलेट कर लो. ट्रांस कंडक्टेंस GM कैन बी रिटन लाइक दिस, म्यू P COX W by L into VSG minus mod VT. दिस पैरामीटर गिवन 1 मिली. VSG हमने निकाला था 1.9365 माइनस 0.5. इज दैट ओके? VSG हमने यहाँ कैलकुलेट किया था 1.9365. तो यहां से आप GM फाइंड करिए बेटा. पहले 1.9365 माइनस 0.5, 1.4365 millimho. It will be in millimho. Next, you show this current in upward direction. It will be minus GM VGS. So what will be output voltage? Minus GM VGS into RD. ठीक है. And अगर आप यहाँ पर KVL अप्लाई करेंगे, if you apply KVL here like this, okay, KVL, you will get minus VI plus VGS plus GM VGS into RS is equal to 0. Remember, this current will flow here. Okay, GM VGS flows into this RS. तो अगर आप KVL अप्लाई करेंगे, you will get minus VI plus VGS plus GM VGS into RS equal to 0. या फिर हम ऐसे लिख देंगे VI equal to VGS into 1 plus GM RS. Now you calculate gain. V0 upon VI. V0 आप लिख दो minus GM VGS into RD. Okay, minus GM VGS into RD डिवाइडेड बाई वी आई। वी आई के प्लेस में आप लिखिए वी जी एस इंटू 1 प्लस जी एम आर एस। ये वी जी एस वाला टर्म कैंसिल हो जाएगा एंड यू विल गेट वोल्टेज गेन इन दिस वे माइनस जी एम इंटू आर डी बाई 1 प्लस जी एम आर एस। इसको आप एज ए फॉर्मूला याद रखिए। बिल्कुल इसी तरह का फॉर्मूला हम कॉमन एमीटर में भी यूज करते हैं। कॉमन एमीटर विदाउट बाईपास माइनस जी एम इंटू आर सी बाई 1 प्लस जी एम इंटू आर ई, राइट। कॉमन सोर्स एंड कॉमन एमीटर एम्पलीफायर, देयर फॉर्मूले आर सिमिलर। ओके, अब आप यहां से वोल्टेज गेन फाइंड करिए बेटा। पुट ऑल द वैल्यूज एंड कैलकुलेट गेन। जी एम इंटू आर डी, आर डी कितना है 5K डिवाइडेड बाई 1 प्लस जी एम इंटू आर एस। आर एस आई थिंक 2K, राइट। आर एस का वैल्यू कितना है 2K। आई एम गेटिंग ए वैल्यू 1.85 माइनस 1.854 माइनस 1.854। So this is the voltage gain of this common source amplifier without bypass capacitor. And in the same amplifier अगर आप bypass capacitor यूज करेंगे, अगर आप यहाँ पर एक bypass capacitor यूज करेंगे इस तरह से, let us say हमने यहाँ पर एक bypass capacitor कनेक्ट किया between source terminal and ground. Now it will be called common source amplifier with bypass capacitor. And for this amplifier voltage gain will be minus gm into rd. ओके, तो इलेक्ट्रिकल बैच के लिए मैं कहना चाहूंगा कि कॉमन सोर्स अच्छे से पढ़ लो फ्रॉम मॉसफेट टॉपिक। कॉमन सोर्स एम्पलीफायर विथ बाईपास कैपेसिटर एंड विदाउट बाईपास कैपेसिटर। एंड इलेक्ट्रॉनिक्स बैच आपको सारे कॉन्फ़िगरेशंस आने चाहिए। कॉमन सोर्स एम्पलीफायर, कॉमन ड्रेन एम्पलीफायर एंड ऑल्सो कॉमन गेट एम्पलीफायर। फॉर इलेक्ट्रॉनिक्स बैच MOSFET is a very very important topic. Okay, तो electronics batch please prepare MOSFET topic thoroughly. Let us move to the next question. Okay, one more question about P channel MOSFET. Here also I have shown a P channel MOSFET and it is a MSQ. You have to calculate RD and RS. This is a DC analysis question. You have to do DC analysis, right? Through some DC analysis, calculate RD and RS. कैसे प्रोसीड करेंगे? कुछ पैरामीटर्स गिवन है। थ्रेशोल्ड वोल्टेज -0.8 एंड म्यू पी COX W/L 100 माइक्रो एम्पियर पर वोल्ट स्क्वायर। VSD गिवन है। VSD वोल्टेज बिटवीन सोर्स एंड ड्रेन, ये वाला वोल्टेज गिवन है 6 वोल्ट। एंड करंट इज गिवन। PMOS में करंट हम ऐसे शो करेंगे, ID और ISD आप कुछ भी शो कर सकते हैं। ISD लेटर से वही करंट यहाँ पर भी फ्लो करेगा, ISD। ओके, और यहाँ पर आप शो करिए VSG वोल्टेज बिटवीन सोर्स एंड गेट। फर्स्ट ऑफ ऑल यू कैन अस्यूम MOSFET इन सैचुरेशन। ओके, सैचुरेशन रीजन इज ए डिफॉल्ट इन द क्वेश्चन। अगर ऑपरेटिंग रीजन मेंशन नहीं है, यू कैन कंसीडर MOSFET इन सैचुरेशन रीजन। तो आप करंट इक्वेशन यूज करिए बेटा। ISD इक्वल टू म्यू पी COX डिवाइडेड बाई 2 इंटू W/L इंटू VSG माइनस मॉड VT होल स्क्वायर। करंट कितना है 150 माइक्रो एम्पियर and this parameter given 100 micro divided by 2 into VSG minus 0.8 whole square. Mod VT will be 0.8. तो यहां से आप पहले VSG कैलकुलेट करो। VSG, ओके, ट्राई टू कैलकुलेट VSG। कुछ कैंसिलेशंस करिए। ये 50 था, 50 कैंसिल होकर यहाँ 3 बचेगा। 3 is equal to VSG minus 0.8 whole square. Take root and get VSG from here. Root 3 plus 0.8. Okay. Take root 3 is equal to VSG minus 0.8. So it will be 0.8 plus root t, 2.532. I am getting VSG 2.532 volt. You will get one more root which will be less than mod Vt. उसको आप ignore करिए. For P channel MOSFET, VSG should be greater than mod Vt. You may get one more root here that will be less than mod Vt. उसको आप ignore करिए. ठीक है. तो VSG यहाँ पर 2.532 है. You can calculate RS. आप RS को ऐसे फाइंड करना, अप्लाई KVL हियर, ऐसे KVL अप्लाई कर लो. KVL 6 is equal to ISD into RS plus VSG. Okay, I have applied a KVL here. 6 is equal to ISD into RS plus VSG, and this drop will be 0 because gate current is 0. In MOSFET gate current 0 होता है, तो drop in 1 mega ohm it will be 0. तो यहाँ से आप RS फाइंड कर लो बेटा. 6 minus 2.532 डिवाइडेड बाई करंट को हम लिख देंगे मिली एम्पियर में 0.15 मिली एम्पियर. आई विल गेट रेजिस्टेंस इन किलो ओम्स. 6 minus 2.532 divided by 0.15, 23.12 kilo ohms, 23.12 kilo ohm. So option D we can take as correct, option C will be wrong. Then we have to find RD also. It is an MS2, तो हमें RD भी फाइंड करना होगा. To calculate RD आप बस ऐसे KVL अप्लाई कर लो. Another KVL like this. Uh, 6 is equal to ISD into RS plus VSD plus ISD into RD minus 6. ओके, मैंने KVL यहाँ पर अप्लाई किया है. 6 is equal to ISD into RS plus VSD plus ISD into RD minus 6. तो यहाँ से आप RD कैलकुलेट करना बेटा. RD rearrange and calculate. Calculation part I leave it to you. अगर आप इसको कैलकुलेट करेंगे तो यू विल बी गेटिंग ए वैल्यू लाइक दिस. $16.88 किलो ohms, 16.88 किलो ohms. So we can say option A is correct here, B is wrong. So finally, what are the correct options? A, D. In this MSQ, the correct options are A and D. Yes, Anuj, A and D are correct. Deliberately I have taken questions on P channel MOSFET. We normally solve good number of questions on NMOS. तो N channel MOSFET सबके लिए फेमिलियर होगा, सबको अच्छे से आता होगा, राइट. उसीलिए मैंने क्वेश्चंस यहाँ पर सॉल्व किए हैं ऑन P channel MOSFET, so that you get an idea about PMOS also. Then let us look at another question. Now this is a current mirror based question. Okay, आपने current mirror वाला टॉपिक अच्छे से पढ़ा होगा. These MOSFETs M2, M3, M4, they are forming a current mirror. Okay, M2, M3, M4, they are forming a current mirror. Now in this problem, some parameters are given. You have to find maximum RD for which M1 operates in saturation. Calculate maximum RD for which M1 operates in saturation region. पहले आप ये देखिए बेटा कि M2, M3, M4 they have identical parameters. M1 has different parameter, mu COX W by L of M1 is different, and for remaining MOSFETs parameters are same. तो यहाँ पर M2, M3, M4 identical हैं, right? M2, M3, M4 are identical. If you look at M3, M4, their drain shorted to gate, so they will be in saturation. You know it very well. When drain shorted to gate, that MOSFET will be in saturation region, and they are in series also. तो दोनों का करंट भी सेम होगा, राइट? तो अब आप ऑब्जर्व ये करिए कि दिस MOSFETs आर आइडेंटिकल, बोथ आर इन सैचुरेशन एंड दे हैव सेम करंट ऑल्सो, क्योंकि दोनों सीरीज में है, दोनों का करंट सेम होगा. तो अगर ये तीन कंडीशंस प्रेजेंट हो, यानी कि MOSFETs आइडेंटिकल हैं, दोनों सैचुरेशन में हैं और दोनों का करंट भी सेम है, देन देयर VGS मस्ट बी सेम. दोनों का VGS अपने आप इक्वल हो जाएगा. ओके, तो अगर मैं यहां पर VGS शो करता हूं, लेट अस से VGS4, दिस इज VGS3, they will be equal. Okay, I repeat again, these are identical MOSFETs, both are in saturation and they have same current also. तो दोनों का VGS अपने आप इक्वल हो जाएगा. वो आप करंट इक्वेशन से भी देख सकते हैं. अगर आप दोनों की करंट इक्वेशन को इक्वेट करेंगे, यू विल गेट द कंडीशन VGS3 इक्वल टू VGS4. ओके, VGS3 VGS4 यहां पर इक्वल है. एंड इफ यू अप्लाई KVL हियर लाइक दिस, अगर आप ऐसे KVL अप्लाई करो इस तरह से, ओके, यू विल गेट VGS4 प्लस VGS3 माइनस 5 इज इक्वल टू 0. KVL अप्लाई किया है मैंने. VGS4 प्लस VGS3 माइनस 5 इज इक्वल टू 0. तो यहां से हम लिख सकते हैं VGS3 इज इक्वल टू, और VGS4 इज इक्वल टू एनीथिंग 2.5. ओके, VGS3 VGS4 इक्वल हैं, तो दे शुड बी लाइक 2.5 प्लस 2.5. तो उस तरह से ये इक्वेशन बनेगा. बोथ हैव ए VGS हाउ मच, 2.5. अब आप करंट कैलकुलेट करो. IDS3, you can use current equation mu n COX by 2 into W by L into VGS minus VT whole square. This is how we write current for n channel MOSFET. Current in n channel MOSFET हम इस तरह से लिखेंगे. अब ये पैरामीटर गिवन है. रिमेनिंग MOSFETs they have mu n COX W by L how much, 0.4 divided by 2 into 2.5 minus VT how much, 1 volt whole square. तो यहां से आप करंट का वैल्यू कैलकुलेट करिए बेटा. वन 1.5 स्क्वायर, ओके, इंटू 0.2, 0.45. आई एम गेटिंग करंट वैल्यू हाउ मच, 0.45 मिली एम्पियर. इज दैट ओके? Then you can use property of a current mirror. Output current same as input current. इसको हम कहेंगे input current and this will be called output current. Okay, आप current mirror की property यूज करिए. M2, M3, M4 they are forming a current mirror, right? अब ये MOSFETs identical भी हैं, M2, M3 identical है, तो जो करंट यहाँ फ्लो करेगा वही करंट यहाँ पर भी फ्लो करेगा. ओके, तो हम करंट मिरर प्रॉपर्टी यूज करेंगे. IDS2 equal to IDS3. Okay, it will be 0.45 milliampere, 0.45 milliampere. Is that okay? Next, M1 M2 सीरीज में है, तो जो करंट M2 में फ्लो करेगा वही करंट M1 में भी फ्लो होना चाहिए, राइट? दोनों के पैरामीटर्स डिफरेंट है, नो डाउट, बट दोनों सीरीज में है, तो आपको सीरीज कनेक्शन वाला प्रॉपर्टी यूज करना होगा. जब दो डिवाइसेस सीरीज में होंगे तो दोनों का करंट सेम होना ही चाहिए, राइट? M1 M2 आर इन सीरीज, तो दोनों का करंट सेम होगा. IDS1 इक्वल टू IDS2 इज इक्वल टू 0.45 मिली एम्पियर। ठीक है, अब आप VGS1 कैलकुलेट करिए बेटा। VGS1 यूज करंट इक्वेशन, करंट इक्वेशन यूज करके VGS1 का वैल्यू फाइंड करिए। IDS1 इक्वल टू म्यू एन COX by 2 into W by L into VGS1 minus VT whole square। ओके, करंट का वैल्यू आप लिख दो 0.45 मिली एम्पियर इज इक्वल टू दिस पैरामीटर हाउ मच 0.8 M1 has this parameter how much 0.8 divided by 2 into VGS1 minus 1 whole square। okay, try to get VGS1, please calculate this value। ये हो जाएगा 0.4, you bring it here 0.45 divided by 0.4 and then apply root plus 1 2.06, I am getting VGS1 2.06 volt। next you can show here current, this is IDS1, okay, and your voltage आप लिख दो VDS1 and what you do next is अब आप ऐसे KVL अप्लाई करो यहाँ पर KVL in this way, KVL 5 is equal to IDS1 into RD plus VDS1 minus VGS1। ओके, मैंने KVL अप्लाई किया है। 5 is equal to IDS1 into RD plus VDS1 minus VGS1। हमें अल्टीमेटली RD का वैल्यू फाइंड करना है। ठीक है, तो यहां से हम लिख सकते हैं VDS1 is equal to 5 plus VGS1, okay, minus IDS1 into RD। VDS1 we will get it like this। Now apply the condition, हमें M1 को saturation region में ऑपरेट करना है। क्वेश्चन पढ़िए बेटा, फाइंड मैक्सिमम RD फॉर विच M1 ऑपरेट्स इन सैचुरेशन। तो अब हम कंडीशन यूज करेंगे, कंडीशन फॉर सैचुरेशन रीजन। व्हाट इज द कंडीशन फॉर सैचुरेशन रीजन? VDS must be greater than or equal to VGS minus VT। तो वो कंडीशन अप्लाई करना। ओके, लेट अस अप्लाई दिस कंडीशन। M1 operates in saturation if VDS1 greater than or equal to VGS1 minus VT। अब VDS1 की प्लेस में लिख दो 5 प्लस VGS1 माइनस IDS1 into RD मोर देन और इक्वल टू VGS1 माइनस VT। अब दोनों साइड से VGS1 वाला टर्म कैंसिल हो गया, इसको आप रीअरेंज करके RD का वैल्यू फाइंड करना। RD लेस देन और इक्वल टू 5 प्लस VT डिवाइडेड बाई IDS1, 5 प्लस 1 डिवाइडेड बाई 0.45, RD लेस देन और इक्वल टू 6 डिवाइडेड बाई 0.45। आई होप आई हैव डन द कैलकुलेशन करेक्टली। VT कितना है बेटा? VT गिवन था ना 1 वोल्ट, राइट। तो इस तरह से आप RD निकाल लेना। ओके, एंड प्लीज लेट मी नो योर आंसर। $13.33 kilo ohms, 13.33 kilo ohms। So this is the maximum RD, max RD is equal to 13.33 kilo ohms Such question can be given for 2 marks in the gate paper. Okay, it's a question about current mirror. Current mirror is also an important area from where questions can come in the gate. Yes, Chandan, 13.33 kilo ohm is the correct answer. Alright, let us go to the next question. Look at this question now, right? There are 2 MOSFETs connected here, and these MOSFETs have same parameters. DC drain current and VDS, दोनों का DC drain current given है 0.4 milliampere and they have a VDS 2.5. Okay, दोनों का VDS भी given है. This is your VDS. Given how much? 2.5. आप यहां पर भी दिखा सकते हैं 2.5. एंड R1 plus R2 plus R3 300 kilo ohm, RS 10K and VI 5 sin omega t millivolt. Then you have to decide which of these options are correct. It is an MSQ, multiple select question, so more than one option can be correct here. तो हमें सारे ऑप्शंस चेक करने होंगे, राइट? चलिए कैलकुलेट करते हैं 1 by 1. ठीक है, क्वेश्चन देखे घबराना मत, आसानी है, कैलकुलेशन थोड़ा ज्यादा होंगे बट आंसर निकल आएगा. ठीक है, लेट अस ट्राई दिस क्वेश्चन नाउ. फर्स्ट ऑफ ऑल करंट का वैल्यू गिवन है, करंट यहां पर गिवन है, तो आप ये करिए बेटा कि RD फाइंड कर लो. RD तो डायरेक्टली निकल जाएगा KVL के थ्रू. आप करंट दिखा दो IDS, यहां पर भी करंट IDS ही फ्लो करेगा. इन दिस RS ऑल्सो करंट विल बी IDS. ओके, तो आप एक KVL ऐसे अप्लाई करना, KVL यहां अप्लाई कर लो. KVL 5 is equal to IDS into RD plus 2.5 plus 2.5. okay, plus IDS into RS minus 5. Remember in DC calculation capacitor will be open circuit. ठीक है, तो बस आप ऐसे KVL अप्लाई कर लो. 5 is equal to IDS into RD plus 2.5 plus 2.5 plus IDS RS minus 5. तो यहां से आप RD इजीली फाइंड कर सकते हैं, राइट? तो RD का वैल्यू फाइंड करिए बेटा. RD इक्वल टू ये 2.5 2.5 और माइनस 5 कैंसिल हो जाएगा. RD इक्वल टू 5 माइनस IDS इंटू RS. IDS कितना है? 0.4 मिली एंड RS 10K डिवाइडेड बाई 0.4. तो इट इज लाइक 1 डिवाइडेड बाई 0.4. 2.5 किलो ओम्स. RD 2.5 किलो ओम्स, यानी कि ऑप्शन ए यहां पर सही है. RD 2.5 के. ठीक है, फिर हम R2 फाइंड करेंगे. R2, लेट अस कैलकुलेट R2. तो उसके लिए आप ऐसे प्रोसीड करना, यू कैलकुलेट हियर VGS1. VGS1 VGS2 दोनों इक्वली होंगे क्योंकि MOSFETs आइडेंटिकल हैं, दोनों का करंट भी सेम है और दोनों को हम सैचुरेशन में मानेंगे. इट इज एन एम्पलीफायर, राइट? एम्पलीफायर का मतलब ही ये होता है कि MOSFET शुड बी इन सैचुरेशन. तो मैं फिर से कह देता हूँ, MOSFETs आइडेंटिकल हैं, दोनों का करंट भी सेम है और दोनों सैचुरेशन में है, तो दोनों का VGS सेम होगा. VGS1 VGS2 इट विल बी इक्वल. अब हम करंट इक्वेशन यूज करके VGS कैलकुलेट करेंगे. IDS इक्वल टू म्यू एन CO x by 2 इंटू W by L इंटू VGS माइनस VT होल स्क्वायर। करंट आप लिख दो बेटा 0.4, करंट का वैल्यू कितना है 0.4 एंड दिस पैरामीटर इज 1.6 डिवाइडेड बाई 2 इंटू VGS माइनस VT 1.2 होल स्क्वायर। तो यहां से आप VGS कैलकुलेट करना, 0.4 डिवाइडेड बाई 0.8, फिर उसका आप रूट लिखिए, रूट उसमें 1.2 ऐड कर दो, 1.907। You may get one more root that you can ignore. VGS should be greater than VT. ये कंडीशन आप याद रखना। N channel MOSFET will conduct if VGS greater than VT. You may get one more root here जो कि लेस देन VT होगा, उसको हम इग्नोर करेंगे, ठीक है। तो ये वाला रूट सही माना जाएगा 1.907, इट इज ग्रेटर देन VT। नेक्स्ट व्हाट, अब हम VG1 कैलकुलेट करेंगे, वोल्टेज एट गेट ऑफ M1, इट विल बी VGS1 प्लस IDSRS माइनस 5। VG1 इज इक्वल टू VGS1 प्लस IDSRS minus 5. I am trying to calculate voltage at the gate of M1, VGS1 plus IDSRS minus 5. Okay, VG1 is equal to VGS1 हमने फाइंड किया है 1.907 plus 0.4 into 10, it will become 4 minus 5. तो ये हो जाएगा 0.907 वोल्ट। Okay, then this R1, R2, R3, they are forming a voltage divider, they are in series. In DC analysis, R1, R2, R3 are considered in series. तो 5 वोल्ट यहाँ पर डिवाइड होगा between R1, R2, R3। अगर आपको VG1 फाइंड करना हो, you can apply voltage divider 5 into R3 by R1 plus R2 plus R3। Okay, मैं लिख देता हूँ, let me write in the next slide. Voltage divider VG1 is equal to 5 into R3 by R1 plus R2 plus R3। VG1 हमने निकाला है 0.907, राइट? हाउ मच? 0.907 is equal to 5 into R3 divided by 300। R1 plus R2 plus R3 वो क्वेश्चन में गिवन है 300 के। तो यहां से आप R3 फाइंड करिए बेटा, 300 into 0.907, ठीक है, एंड डिवाइडेड बाई 5, 54.42। इस तरह से हमने R3 फाइंड किया, बट हमें फाइंड करना है R2। अवर एम इज टू फाइंड R2। तो पहले हमने R3 फाइंड किया दिस मच, अब हम R2 फाइंड करेंगे, ठीक है। टू कैलकुलेट R2 व्हाट यू डू इज यू राइट VG2 वोल्टेज एट गेट ऑफ M2। वो कैसे लिखेंगे? वो ऐसे लिख देंगे VGS2 प्लस 2.5 प्लस IDSRS माइनस 5। ओके, गेट ऑफ M2 वहां का वोल्टेज कितना होगा? VGS2 प्लस 2.5 प्लस IDSRS माइनस 5। ओके, यू ट्रेवल लाइक दिस। मैं लूप दिखा देता हूं, आप इस तरह से ट्रेवल करना लाइक दिस। ओके, VG2 is equal to VGS2 plus 2.5 plus IDSRS minus 5। VGS2 1.907, okay, VGS1 VGS2 both will be same, VGS1 VGS2 both will be 1.907 plus 2.5, 0.4 into 10 ये 4 हो जाएगा, माइनस 5। तो इस तरह से आप Vg2 लिख देना, कितना आएगा बेटा 1.907, ये हो गया -1 1.5 प्लस 1.5 इट इज 3.407. देन अगेन अप्लाई वोल्टेज डिवाइडर Vg2. Vg2 का मतलब होता है वोल्टेज बिटवीन गेट ऑफ M2 एंड ग्राउंड. R2 R3 सीरीज में है, तो अगर आप इस नोड का वोल्टेज लिखते हैं विथ रिस्पेक्ट टू ग्राउंड, इट विल बी 5 इंटू R2 प्लस R3 डिवाइडेड बाई R1 प्लस R2 प्लस R3, वोल्टेज डिवाइडर. ओके, Vg2, लेट मी राइट हियर, 5 इंटू R2 प्लस R3 divided by R1 plus R2 plus R3. I hope everybody understood the technique here. Vg2 is nothing but voltage between gate of M2 and ground. इस नोड से ग्राउंड के बीच में you have R2 R3 in series, यानी कि R2 plus R3 is the net resistance, right? तो Vg2 कितना होगा 5 into R2 plus R3 divided by R1 plus R2 plus R3. तो इस तरह से आप R2 फाइंड कर सकते हैं. ओके, Vg2 आप लिख दो 3.407 is equal to 5 into R2 plus R3 डिवाइडेड बाई 300. इसको आप सॉल्व करिए बेटा. R2 plus R3 is equal to 204.42. I'm getting it as 204.42. हमें R3 का पता है, R3 हमने कैलकुलेट किया था 54.42, वो आप यहाँ पे पुट कर दो 54.42 एंड गेट R2. You will get R2 equal to 150 किलो ohms. ओके, 204.42 माइनस 54.42 वो 150 के बराबर आएगा, 150 किलो ohms. ओके, इतना सब कुछ करके हमें पता ये चला कि ऑप्शन बी इज इनकरेक्ट. ऑप्शन बी R2 गिवन एज 100K, जो कि रॉन्ग है. ऑप्शन बी इज रॉन्ग. R2 हाउ मच 150K, तो 100K विल बी रॉन्ग. तो इस तरह से हमने R2 फाइंड किया. लेट अस नाउ सी अदर बिट्स. AC आउटपुट वोल्टेज. टू कैलकुलेट AC आउटपुट वोल्टेज we need to know voltage gain. Okay, that Vi is a AC input and we have to find AC output voltage. To calculate AC output voltage I should find voltage gain V naught by Vi. तो उसके लिए हम पहले ट्रांस कंडक्टेंस फाइंड करेंगे GM. ओके, एंड लेट अस कैलकुलेट GM, ट्रांस कंडक्टेंस. दोनों मॉसफेट्स के लिए GM सेम रहेगा. GM1 इक्वल टू GM2 इक्वल टू म्यू एन COX W by L into VGS minus VT. This parameter how much? 1.6 into VGS how much? 1.907 minus VT 1.2. Okay, threshold voltage 1.2. तो इस तरह से आप ट्रांस कंडक्टेंस फाइंड करना. 1.907 minus 1.2 into 1.6, 1.1312 millimole. And you can take R0 parameter as infinite. There is nothing mentioned about RDS or R0, so we take it as infinite. Next we will calculate voltage gain. अब हम voltage gain find करेंगे. This is actually a multi-stage amplifier. इसको हम कहेंगे cascode amplifier. This type of circuit is called cascode. You must be knowing this name. Multi-stage वाले टॉपिक में आपने दो एम्पलीफायर पढ़े होंगे, डार्लिंगटन एम्पलीफायर एंड कैस्कोड एम्पलीफायर. डार्लिंगटन एम्पलीफायर is a cascade of two common collector amplifiers. Then we also have cascode. This circuit is a cascode amplifier. It is a cascade of common source and common gate. M1 यहाँ पर कॉमन सोर्स कॉन्फ़िगरेशन में है, क्योंकि इनपुट हमने अप्लाई किया है गेट पर, सोर्स टर्मिनल ग्राउंड हो जाएगा। जब आप C2 को शॉर्ट सर्किट से रिप्लेस करेंगे तो सोर्स विल बी ग्राउंडेड, कॉमन सोर्स एम्पलीफायर, राइट। ड्रेन विल बी आउटपुट नोड। जब आप M2 देखेंगे, M2 के लिए सोर्स इज द इनपुट टर्मिनल, ड्रेन इज द आउटपुट टर्मिनल एंड गेट विल बी ग्राउंडेड। C3 विल बिकम शॉर्ट सर्किट इन आवर AC एनालिसिस, तो गेट विल बी ग्राउंडेड। M2 इज कॉमन गेट, तो इसको हम कहते हैं कैस्केड एम्पलीफायर। ओके, इट इज ए टू स्टेज एम्पलीफायर, इट इज ए कैस्केड ऑफ कॉमन सोर्स एंड कॉमन गेट एंड वी कॉल इट कैस्केड, and we will find out its voltage gain. To calculate voltage gain, you have to replace all capacitors with short circuit, right? Then supply nodes will be disabled or grounded. Okay, ये सारे कैपेसिटर शॉर्ट हो जाएंगे इन अवर AC एनालिसिस। सप्लाई को हम डिसेबल कर देंगे इस तरह से। ओके, देन लुक हियर, M1 का सोर्स टर्मिनल ग्राउंड हो जाएगा, राइट। फिर गेट और ग्राउंड के बीच में VI को दिखाएंगे हम। गेट और ग्राउंड के बीच में R3 भी है, गेट और ग्राउंड के बीच में R2 भी प्रेजेंट है। लुक एट M1, गेट टू ग्राउंड यू हैव R3 एंड गेट टू ग्राउंड यू हैव R2 ऑल्सो, यानी कि R2 R3 पैरेलल में आएंगे बिटवीन गेट ऑफ दिस M1 एंड ग्राउंड। व्हाट अबाउट R1? R1 शॉर्ट सर्किट के पैरेलल में है। गेट ऑफ M2 एंड ग्राउंड यू हैव ए शॉर्ट सर्किट, गेट ऑफ M2 एंड ग्राउंड यू हैव R1 ऑल्सो, यानी कि R1 और शॉर्ट सर्किट पैरेलल में है। रेजिस्टर एंड ए शॉर्ट सर्किट इन पैरेलल, इट विल बिकम शॉर्ट सर्किट ओनली, रेजिस्टर विल बिकम डेड। तो इन अवर AC एनालिसिस R1 विल बिकम डेड। ओके, तो इस तरह से हम सर्किट को रीड्रॉ करेंगे। फिर M1 M2 को हम स्मॉल सिग्नल मॉडल से रिप्लेस करेंगे। M1 M2 विल बी रिप्लेस बाय स्मॉल सिग्नल मॉडल। RD आपका ड्रेन और ग्राउंड के बीच में आ जाएगा। तो इस सर्किट को मैंने यहाँ पर दिखाया है जस्ट टू सेव द टाइम। अब कुछ इस तरह का सर्किट ड्रॉ करेंगे, एक बार सर्किट देख लेना। This is small signal model of M1, this is small signal model for M2। ओके, अगर आप M1 देखेंगे, सोर्स को मैंने ग्राउंड किया है, गेट और ग्राउंड के बीच में मैंने R2 R3 को पैरेलल में दिखाया है, ठीक है, और इनपुट भी हमने शो किया है गेट और ग्राउंड के बीच में। फिर ड्रेन ऑफ M1 कनेक्टेड टू सोर्स ऑफ M2, ड्रेन ऑफ M1 कनेक्टेड टू सोर्स ऑफ M2, वो भी मैंने यहाँ पर दिखाया है, ठीक है। एंड व्हाट एल्स, गेट ऑफ M2 ग्राउंडेड है, जैसे आप यहाँ देख सकते हैं, गेट ऑफ M2 विल गेट ग्राउंडेड, तो मैंने M2 के गेट को ग्राउंड से कनेक्ट किया है, राइट। फिर ड्रेन और ग्राउंड के बीच में हमने RD को शो किया। यहाँ से हम वोल्टेज गेन फाइंड करेंगे। इस करंट को आप दिखा दो ऊपर के डायरेक्शन में, ये हो जाएगा -GM2 इंटू VGS2। सो व्हाट विल बी V0? -GM2 VGS2 इंटू RD, ठीक है। और आप ये भी देख सकते हैं GM2 VGS2 इट विल बी सेम एज GM1 VGS1, यानी कि ये करंट सेम ही है। दिस करंट इज सेम एज दिस करंट। ओके, GM2 into VGS2 is same as GM1 into VGS1। okay, this current will flow in this path, ठीक है, दोनों करंट सेम ही है। then we will write V0 is equal to minus GM2 VGS2 into RD या फिर आप ऐसे भी लिख सकते हैं माइनस GM1 VGS1 into RD। ओके, एंड VI आप यहां से देखिए बेटा, VI विल बी सेम एज VGS1, VI सेम एज VGS1। नाउ यू टेक रेशियो V0 by VI, वो VGS1 वाला टर्म कैंसल हो जाएगा, इट विल बिकम माइनस GM1 into RD। दिस इज द वोल्टेज गेन ऑफ दिस कैस्केड एम्पलीफायर, ठीक है। अब आप वैल्यूज पुट करिए। GM1 हमने कैलकुलेट किया था, हाउ मच 1.1312 एंड RD कितना है, RD भी हमने कैलकुलेट किया था 2.5 के, 1.1312 इंटू 2.5। तो इस तरह से आप वोल्टेज गेन फाइंड कर लेना। इंटू RD 2.5, 2.828 माइनस 2.828। नेक्स्ट कैलकुलेट V0। VI क्वेश्चन में गिवन है माइनस 2.828 इंटू 5 साइन ओमेगा टी। आप एक बार मल्टीप्लाई करके देखना, इंटू 5, 14.14 माइनस 14.14 साइन ओमेगा टी मिली वोल्ट। ओके, तो इस तरह से आप कह सकते हैं कि आपका ऑप्शन सी इज करेक्ट। व्हाट अबाउट ऑप्शन डी, ZI इनपुट इंपीडेंस। व्हाट विल बी इनपुट इंपीडेंस हियर, वो आप सर्किट देख के बता सकते हैं। दिस पैरेलल कॉम्बिनेशन विल बिकम इनपुट इंपीडेंस, ZI इक्वल टू R2 पैरेलल R3, R2 इन पैरेलल टू R3। R2 हमने फाइंड किया था 150 के इन पैरेलल टू आई थिंक 54.42। R3 हमने फाइंड किया है 54.42 एंड R2 150 के। तो अब ये पैरेलल कॉम्बिनेशन फाइंड करिए बेटा। ऑलमोस्ट 40 किलो ओम्स अप्रोक्सीमेटली, इट इज कमिंग आउट एज 39.93। आप इसको अप्रोक्सीमेट कर दो विथ 40 किलो ओम्स। सो इन दिस वे आई थिंक ऑप्शन डी ऑल्सो करेक्ट, ऑप्शन डी भी यहां पर सही है। सो इन दिस MSQ what are the correct options? A, C, D. Option A, C and D are correct. Okay. Now everybody should practice how to analyze amplifiers. Okay. You should be good at replacing transistor with equivalent model. BJT को हम replace करेंगे with pi model. MOSFET will be replaced by this type of small signal model. So in this way we analyze amplifiers. In MOSFET topic especially electronics batch, इसको आप अच्छे से प्रिपेयर करना। MOSFET biasing, MOSFET current mirror, MOSFET amplifiers. Okay, they can also ask you amplifiers having active load, that is also important area. MOSFET amplifier having एक्टिव लोड, वो भी अच्छे से प्रिपेयर करिए। देन हाउ टू कैलकुलेट कट ऑफ फ्रीक्वेंसीज, लोअर कट ऑफ फ्रीक्वेंसी, हायर कट ऑफ फ्रीक्वेंसी। एंड इलेक्ट्रॉनिक्स बैच प्रिपेयर CMOS इन्वर्टर ऑल्सो। इलेक्ट्रिकल बैच MOSFET थोड़ा बेसिक वे में प्रिपेयर करके जाना। इलेक्ट्रिकल स्टूडेंट्स MOSFET का बायसिंग वाला टॉपिक देख लो, हाउ टू डू DC एनालिसिस ऑफ MOSFET एंड कॉमन सोर्स एम्पलीफायर विथ बाईपास, विदाउट बाईपास। दिस मच इज इनफ I think for electrical students, but electronics batch, electronics students आपको MOSFET अच्छे से प्रिपेयर करना होगा। ओके, या फिर मैं ऐसे कह सकता हूँ कि आप MOSFET के लिए जितना भी पढ़ेंगे वो कम ही होगा फॉर इलेक्ट्रॉनिक स्टूडेंट्स। ओके, सो इलेक्ट्रॉनिक्स स्टूडेंट्स प्लीज रिमेंबर MOSFET यू हैव टू बी थरो, राइट। MOSFET बायसिंग पढ़िए, MOSFET करंट मिरर, MOSFET एम्पलीफायर्स। ओके, MOSFET amplifier with active load, how to calculate lower cutoff frequency, higher cutoff frequency and CMOS inverter. These are the areas that electronics batch should prepare thoroughly. Purpose of this session is to give you an idea about what type of questions can come, okay, in the gate paper, and through this I am also telling you what are the important areas that you should prepare for both electronics and electrical gate paper. So I hope this session has helped you in getting an idea, okay, about Rajkumar sir did already diode and BJT circuits. I have taken up MOSFET and op-amp questions. So hopefully this session will help you in your gate preparation, right? So I conclude my session here, and my best wishes to all of you. I sincerely hope that you all will perform really well in the upcoming gate paper. ओके, अब कुछ भी नया नहीं पढ़ना है, आपने जो भी पढ़ा है अब तक उसको अच्छे से रिवाइज करिए. यू माइट हैव प्रिपेयर्ड शॉर्ट नोट्स, तो शॉर्ट नोट्स का रिवीजन करिए एंड कीप सॉल्विंग क्वेश्चंस. दिस इज द टाइम वेयर यू शुड बी प्रैक्टिसिंग, राइट, मोर नंबर ऑफ क्वेश्चंस. यू कैन अपीयर इन द टेस्ट सीरीज विथ फुल सिंसियरिटी. टेस्ट सीरीज को अच्छे से एनालाइज करिए. ओके, सॉल्व PYQs, एटलीस्ट लाइक लास्ट 10 to 15 years of PYQs you must be thorough. Okay, and don't study anything new from here onwards. Focus more on revising whatever you studied already, right? Do your PYQs and appear in the test series. So once again, my best wishes to all of you. Thank you for your patience. Thank you. Saptarshi Biswas is asking some more questions on MOS amplifier. I actually prepared some questions here, but the time is a factor. If you want beta, I will show you the question slide. उसको आप एक बार try करना. और let me take one active load question. I will try one active load question. ये आप अपने आप से ट्राई कर लेना. ये वाला क्वेश्चन मैं इसका स्लाइड आपको दिखा देता हूँ. ये क्वेश्चन ट्राई करिए बेटा. इसका आंसर आएगा 0.35 वोल्ट. 0.35 वोल्ट, इसको ट्राई कर लेना, ठीक है. बस आपको करंट इक्वेट करना होगा. इनपुट 5 वोल्ट है. ये एक्चुअली इन्वर्टर की तरह यूज होता है. इट विल बी यूज्ड एज ए इन्वर्टर इन डिजिटल इलेक्ट्रॉनिक्स. इनपुट आपने दिया है 5 वोल्ट, तो आउटपुट शुड बी 0, राइट, समथिंग लाइक दैट. इनपुट अगर लॉजिक 1 है तो आउटपुट शुड बी लॉजिक 0. वो वाला कॉन्सेप्ट अप्लाई करेगा. लॉजिक 0 का मतलब आउटपुट वोल्टेज वेरी वेरी स्मॉल. तो वहां से आपको आइडिया मिलेगा कि यहाँ का VDS लेस देन VGS माइनस VT होगा. तो ये वाला MOSFET ट्रायोड रीजन में है. यहाँ पर M1 को आप ट्रायोड रीजन में लेके चलना, M2 आपका सैचुरेशन में है. फिर दोनों का करंट इक्वेट करके यू कैलकुलेट V0. ओके, आई रिपीट अगेन, M2 सैचुरेशन में है क्योंकि ड्रेन शॉर्टेड टू गेट है. M1 को हम ट्रायोड में लिखेंगे क्योंकि इसका जो VDS होगा वो बहुत कम होगा. इनपुट आपका लॉजिक 1 है तो आउटपुट विल बी लॉजिक 0. लॉजिक 0 का मतलब वेरी स्मॉल वोल्टेज. तो VDS ऑफ M1 वेरी स्मॉल, इट विल बी लेस देन VGS माइनस VT. तो M1 आपका ट्रायोड रीजन में होगा. तो आप दोनों का करंट इक्वेट करो. ये वाला करंट आप सैचुरेशन से लिखना और ये वाला करंट आप ट्रायोड इक्वेशन से लिख के इक्वेशंस को इक्वेट करो एंड सॉल्व. यू विल गेट V0. यू विल गेट आंसर आई थिंक 0.35 वोल्ट. तो इसको आप ट्राई करना एज ए सेल्फ एक्सरसाइज. ओके, टाइम फैक्टर इज देयर, इट इज नॉट पॉसिबल टू डिस्कस ऑल द क्वेश्चंस, बट आप इसको खुद से ट्राई कर लो. मैंने आपको आइडिया दे दिया है, ठीक है. देन या दिस क्वेश्चन आई विल डिस्कस. दिस इज एन एग्जाम्पल फॉर एक्टिव लोड. दिस मे कम फॉर इलेक्ट्रॉनिक्स बैच. दिस टाइप ऑफ क्वेश्चंस can be asked for electronics students. Okay, so electronics batch आपको ऐसे वाले questions solve करने पड़ेंगे, ठीक है. That M2 M3 are forming a current mirror. That current mirror is a load for M1. Okay, this current mirror will act as a load for M1. अब आप M1 को देखिए. इनपुट हमने सोर्स पर अप्लाई किया है एंड आउटपुट टेकन फ्रॉम ड्रेन, यानी कि M1 इज ए कॉमन गेट एम्पलीफायर. यहां पर M1 एक्टिंग लेके कॉमन गेट एम्पलीफायर. मैं लिख देता हूं M1 कॉमन गेट एम्पलीफायर. ओके, एंड M2 M3 आर फॉर्मिंग ए करंट मिरर. और आपको अच्छे से पता है इन AC एनालिसिस करंट मिरर को हम रिप्लेस करेंगे विथ इक्विवेलेंट रेजिस्टेंस. ओके, करंट मिरर विल बी रिप्लेस्ड बाय इक्विवेलेंट रेजिस्टेंस. M2 and M3 they form current mirror. तो इसका R इक्विवेलेंट यूज करना आप. व्हाट विल बी इक्विवेलेंट रेजिस्टेंस ऑफ करंट मिरर? इट विल बी R0 ऑफ M2. ये सबको पता होना चाहिए. करंट मिरर हैज ए आउटपुट रेजिस्टेंस और इक्विवेलेंट रेजिस्टेंस. हाउ मच? R0 of M2 और RDS of M2. R equivalent will be R0 2. ओके, तो हम सर्किट को ऐसे रीड्रॉ कर लेंगे. करंट मिरर यहां पर रिप्लेस हो जाएगा विथ इक्विवेलेंट रेजिस्टेंस R0 2. इन अवर AC एनालिसिस VDD विल बी ग्राउंडेड, तो ये ग्राउंड हो गया. यहां पर आप इनपुट शो करेंगे. V बायस इज ए DC वोल्टेज, तो वो भी ग्राउंड हो जाएगा इन AC एनालिसिस. So given amplifier we can redraw in this way. Okay, current mirror को हमने ट्रांसफॉर्म किया into equivalent resistance and V bias node grounded, gate grounded. ठीक है, और यहां पर मैंने शो किया है इनपुट. इट इज एक्चुअली ए कॉमन गेट एम्पलीफायर. आउटपुट टेकन फ्रॉम ड्रेन. अब आप पहले ट्रांस कंडक्टेंस वगैरह कैलकुलेट करिए. करंट का वैल्यू गिवन है. आई थिंक आई बायस कितना है बेटा? 0.4 मिली एम्पियर. ये आपका आई बायस है 0.4. तो वही करंट यहाँ पे भी फ्लो करेगा. करंट मिरर का प्रॉपर्टी यूज करेंगे. आउटपुट करंट इक्वल टू इनपुट करंट. अगर यहाँ करंट 0.4 मिली है तो यहाँ का करंट भी होगा 0.4 मिली. तो इस तरह से आप ट्रांस कंडक्टेंस फाइंड करिए. GM1 यू कैन कैलकुलेट GM1. आप ये वाला फॉर्मूला यूज कर लेना. रूट ऑफ 2 mu n COX W by L into IDS. There are multiple formulae for trans conductance. यहाँ पर ये वाला फॉर्मूला यूजफुल होगा क्योंकि हमें करंट का वैल्यू पता है. करंट इज 0.4 मिली. तो इस तरह से आप GM1 फाइंड कर लो. इट इज 2 into mu n COX W by L. हाउ मच? mu n COX W by L 0.8 and current is how much beta? 0.4 under root. It will come out as 0.8 millimho. फिर आप R0 भी कैलकुलेट कर लो. R0 1 R0 2 दोनों सेम ही होंगे. They will be 1 by lambda into IDS. ओके, लैम्डा का वैल्यू गिवन है 0.01 वोल्ट इनवर्स. We use lambda in the calculation of RDS और R0. रिमेंबर, लैम्डा को हम यूज करेंगे इन द कैलकुलेशन ऑफ R0 और RDS. ठीक है, तो यहां से आप R01 R02 फाइंड करना. इट इज 0.01 into 0.4 इन द डिनोमिनेटर. इसका आप इनवर्स लिखिए. 250 किलो ओम्स. 250 किलो ओम्स. ओके, नेक्स्ट we will replace M1 with a small signal model. We need to replace M1 with small signal model. तो वो बस सर्किट मैंने शो किया है in the next slide. M1 replaced by small signal model. Gate grounded. Source और ground के बीच में मैंने VI को शो किया है. And between drain and ground you have R02. I hope everybody understood this step. This small signal model of M1. ठीक है, देन गेट ग्राउंडेड है. गेट को मैंने ग्राउंड किया है. सोर्स से ग्राउंड के बीच में हमने VI को शो किया. ड्रेन और ग्राउंड के बीच में हमने R02 को कनेक्ट किया है इस तरह से. ओके, एंड फ्रॉम हियर वी शुड फाइंड आउट वोल्टेज गेन. नाउ यू नीड टू यूज सम टेक्निक्स ऑफ नेटवर्क्स. यू नीड टू यूज हियर सम नेटवर्क एनालिसिस टेक्निक्स. फॉर एग्जाम्पल आई कैन अप्लाई वन KVL हियर. एक KVL ऐसे अप्लाई कर लो. KVL, you will get VGS plus VI equal to 0, or you can say VGS equal to minus VI. Take it as equation 1. ठीक है, अब आप एक KCL अप्लाई करो बेटा. KCL ऐसे अप्लाई कर लो. Sum of these currents equal to 0. KCL at drain. KCL at drain. This current plus this current plus this current equal to 0. KCL GM1 into VGS, okay, plus what will be current here? It will be, this voltage is V0, right? V0 minus VI by R01. plus what will be current here, V0 upon R02 is equal to 0, like this. Once you replace MOSFET with small signal model, then automatically your networks analysis techniques should come in the mind. मैंने एक KVL ऐसे अप्लाई किया है, फिर मैंने एक KCL अप्लाई किया, राइट, दिस करंट प्लस दिस करंट प्लस दिस करंट, दैट सम इक्वल टू 0. अब आप VGS की प्लेस में लिख दो माइनस VI, इसको थोड़ा शफल कर लेना, V0 इंटू 1 बाई R01 प्लस 1 बाई R02 इज इक्वल टू VI इंटू GM1 प्लस 1 by R01. You will get equation like this. V0 Vi को आप सेपरेट कर लो. V0 by Vi equal to it will be GM1 plus 1 by R01 divided by 1 by R01 plus 1 by R02. You will get voltage gain in this way. अब आप यहाँ पर वैल्यूज पुट करिए बेटा and try to find out voltage gain. आप वैल्यूज पुट करिए, GM1 0.8 एंड R01 R02 250 किलो ओम्स है, तो जब आप वैल्यूज लिख देंगे यू विल गेट इट एज 100.5. सो इन दिस कॉमन गेट एम्पलीफायर you will get voltage gain 100.5. अब आप ऑप्शन देखिए बेटा, नियरेस्ट ऑप्शन 100, that will be the answer. Okay, option A, gain approximately equal to 100. So you can get this kind of questions. MOSFET amplifier having active load. Current mirror is an example for active load. Remember, there are other examples also. Drain shorted to gate, that MOSFET can be used as a load. It has a R equivalent 1 by GM in parallel to R0, or gate shorted to source, that is another example for active load. It has a R equivalent equal to R0. Okay, you will find all these things in my notes, तो एक बार रिवाइज कर लेना, ठीक है. एंड किसी ने पूछा है कि वो इन्वर्टर वाला सर्किट हमने कैसे आइडेंटिफाई किया. इकबाल इज आस्किंग हाउ वी आइडेंटिफाई सर्किट इज ए इन्वर्टर. इट इज ए स्टैंडर्ड सर्किट बेटा. दिस इज ए स्टैंडर्ड सर्किट इन डिजिटल इलेक्ट्रॉनिक्स. आपने इसको हम कहते हैं एनमॉस इन्वर्टर. इन्वर्टर को हम कई तरह से फॉर्म कर सकते हैं. दिस इज ए एनमॉस इन्वर्टर विथ ड्रेन शॉर्टेड टू गेट MOSFET acting as a load. We have a CMOS inverter also, and there is a NMOS inverter with depletion MOSFET as a load also. There are multiple inverter circuits. So this is a standard circuit, तो इसलिए मैंने कहा it is a inverter. अगर आप इनपुट देंगे लॉजिक 0, आउटपुट विल बी लॉजिक 1. ओके, इफ यू गिव इनपुट एज ए लॉजिक 1, आउटपुट विल बी लॉजिक 0. यू नीड टू हैव दिस आइडिया. आपने शायद डिजिटल में पढ़ा होगा डिफरेंट टाइप्स ऑफ इन्वर्टर्स. वी कैन मेक इन्वर्टर by using NMOS PMOS, उसको हम कहते हैं CMOS inverter. We can make inverter by using both NMOSFETs also. Both are like enhancement MOSFETs. ऊपर वाले MOSFET के लिए हमने ड्रेन और गेट को शॉर्ट किया है, it will become a load. We can make inverter with depletion MOSFET and enhancement MOSFET also. वो भी इन्वर्टर होगा, ठीक है. तो अगर आपको आइडिया होगा तो सॉल्यूशन थोड़ा आसान हो जाएगा, ठीक है. अगर ये आइडिया दिमाग में है, इट इज एन इन्वर्टर. इनपुट 5 वोल्ट है, तो यहाँ का वोल्टेज ऑलमोस्ट 0 के बराबर होगा, लॉजिक 0. तो इन दैट वे यू कैन डू द एनालिसिस. इज दैट ओके? इन्वर्टर का मतलब नॉट गेट. इट इज एक्टिंग लाइक ए नॉट गेट. सो दिस वाज CMOS कॉमन गेट एम्पलीफायर. इसको हम CMOS कॉमन गेट एम्पलीफायर कह सकते हैं, ठीक है. वी कैन मेक CMOS कॉमन सोर्स एम्पलीफायर ऑल्सो. वो भी गेट में अपियर हो चुका है, आई थिंक 2019 गेट पेपर. वी कैन मेक कॉमन ड्रेन एम्पलीफायर ऑल्सो विथ करंट मिरर एज अ लोड। उसका मैं सर्किट दिखा देता हूँ, उसको आप खुद से एनालाइज कर लेना। These are common source amplifier. M1 will become a common source here. Input node is gate, output node is drain, and source becomes grounded. So it is a common source amplifier. M2, M3 are forming a current mirror. तो इसको हम कहेंगे common source amplifier with active load. तो इसको आप खुद से एनालाइज करना। ये वाला करंट मिरर रिप्लेस हो जाएगा विथ R02। तो इसका आप गेन फाइंड करके देखिए बेटा। फॉर दिस एम्पलीफायर मैं फॉर्मूला लिख देता हूँ, V0 by Vi you will get minus GM1 into R01 parallel R02। ये वाला क्वेश्चन 2019 गेट पेपर में अपीयर हो चुका है, इलेक्ट्रॉनिक्स गेट पेपर। इट वाज ए क्वेश्चन फॉर 2 मार्क्स। ओके, इसको हम कहेंगे CMOS कॉमन सोर्स एम्पलीफायर। करंट मिरर को आप रिप्लेस कर लेना विथ R02, देन M1 को आप स्मॉल सिग्नल मॉडल से रिप्लेस करिए, यू विल गेट वोल्टेज गेन दिस मच। Then I have shown common drain amplifier also with current mirror as a load। आप M1 देखिए बेटा, input node is gate, output taken from source terminal and drain will become grounded। in AC analysis VDD को हम ground करेंगे तो drain will become grounded। common drain, इसको हम कहेंगे common drain amplifier। M2 M3 are forming a current mirror। तो यहाँ पर भी आप current mirror को replace कर लेना with R02 कुछ इस तरह से, R02। ओके, ये आपका VI है, ड्रेन विल बी ग्राउंडेड, दिस इज योर M1। ओके, करंट मिरर रिप्लेस बाय इक्विवेलेंट रेजिस्टेंस। फिर आप M1 को रिप्लेस करना विथ स्मॉल सिग्नल मॉडल एंड ट्राई टू फाइंड आउट वोल्टेज गेन। इसके लिए अगर आप वोल्टेज गेन डिराइव करेंगे तो फॉर्मूला कुछ इस तरह से बनेगा, GM1 इंटू R01 पैरेलल R02 divided by 1 plus GM1 into R01 parallel R02। Okay, it will be like approximately 1 common drain amplifier, it has a voltage gain approximately 1 and ये common source amplifier है तो इसका गेन कुछ इस तरह से आएगा। इसका मैं सिंप्लीफाइड सर्किट दिखा देता हूँ। कॉमन सोर्स के लिए सर्किट कुछ ऐसे बनेगा। लाइक दिस। ओके, करंट मिरर को आप रिप्लेस करेंगे विथ इक्विवेलेंट रेजिस्टेंस R02, सोर्स ग्राउंड हो जाएगा, राइट। तो इसको अगर आप मॉडल बना के सॉल्व करेंगे यू विल गेट वोल्टेज गेन माइनस GM1 इंटू R01 पैरेलल R02। ये आपका कॉमन सोर्स एम्पलीफायर है एंड दिस इज कॉमन ड्रेन एम्पलीफायर। और जो क्वेश्चन मैंने इससे पहले सॉल्व किया है दैट वाज कॉमन गेट। सो दिस आर MOSFET एम्पलीफायर्स विथ करंट मिरर एज ए लोड। सो एक्टिव लोड इज ए इंपॉर्टेंट टॉपिक, स्पेशली इलेक्ट्रॉनिक्स बैच, इसको अच्छे से प्रिपेयर करना। ओके, सो दिस वर सम एक्स्ट्रा टॉपिक्स फॉर इलेक्ट्रॉनिक्स बैच विच आई हैव टेकन अप बिकॉज सम ऑफ यू रिक्वेस्टेड फॉर इट। ओके, सो लेट मी कंक्लूड द सेशन हियर। वंस अगेन माय बेस्ट विशेस, थैंक यू for your patience throughout the session. Okay,